All right, guys, we are starting now. And I want you to be quiet, please. This is being recorded so that you guys can go back and look at the solution later. And noise and recording don't go well together. Hold on a second, let's check something here. Okay. All right. So I want to work through the paper, guys. And as usual, the pass mark today is 85%. By the way, people online, can you hear me?
Yes, sir.
Can you hear me? All right, good. Pass mark is 85%. Anything you got wrong, you need to go and do it over. You don't know what's coming in the exam. Remember, the whole aim of this exercise is to make the mistakes now so that you don't carry those mistakes into the exam room. Make the mistakes now, learn from your mistakes. You have to remember your mistakes. Also discover things that you don't know so well, so you have time to close those gaps, practice them, get clarity on them, and so on. That's the whole aim. So anything you got wrong, you need to go and redo the question, get it right. All right, let's do this. I want to finish this paper. Then we're going to take a break, and then we're going to do another paper today. And the pass mark on the other paper today is still 85%. Don't worry. We're moving it to 90% next week. All right? During the week. Yeah. Let's go. So this is the paper that they set last year, June 2024, 1 year ago. And this is it. All right. First question is to calculate this thing and give the answer to two significant figures. So I'm going to put this in the calculator and see what it is. Just make sure you type it in the calculator exactly as it appears there. So it's a square root of 7.1 squared plus 2.9 squared, like Pythagoras' theorem. That's 7.669 something, but I only want two significant figures. So initially we are getting 7.66941. Well, let's change this to a 2, and so on, right? That's what we're getting. But we really only want two significant figures. Now, the first significant figure is the first non-zero value from left to right. So this is the first significant figure. This is the second significant figure. So we're correcting it to those two figures. So using this digit to correct that 7.6. So this 6 is more than 5. 5 or more will always increase this value. And so to two significant figures, this is equal to 7.7. That is the answer to two significant figures. Anything other than that, you're wrong. 1 mark for it. Anything other than this is incorrect. Next question. They want the same number to two decimal places. So let's write it again. 7.6941 and so on. Now we want two decimal places. Just start counting decimal places. So decimal places that you want to correct. This 9 will correct this 0.66 and turn it into 0.67, increase it by 1. But this again is a number greater than 5. If this number was, for example, 4, then this would have to stay at the will increase this. Everybody should know that by now. So this becomes equal to 7.67. Anything from apart from that is wrong. 1 mark for that. So far. Next question. we have to write these numbers in ascending order, these numbers. Ascending means that you are going from the lowest value to the highest value. So a good way to see these numbers, to see the actual value of these numbers, is to put them all in decimal. So this one is already in decimal, 0.46. This 47%, you must know it is 0.47. So the question is, what is this in decimal? You can actually just divide it and put the 12 divided by 25, 0.48. So this value is 0.48. So this is the smallest one. This is the second one. That's the largest one. So you put the 0.46 first, 0.47. Well, actually I have to put it as it was given, right? My mistake. Right, so this one is okay. But I gave you 0.46. So you put it as it was given. The second one is the 0.47. You put back this, the 47%. Put it as it was given. And the third one is 0.48. But again, you have to put it back as it was given. 12 over 25. So that is it. The request says you must put these in ascending order. So I think you really should be putting these in ascending order. I think if maybe if you put these, they'll give you the marks. Because you're putting that this is equal to that, and that this is equal to, I think they'll give you the marks if you put decimal. So take the mark. Because CSEC wants to give you the mark. CSEC, they're not very harsh in giving marks. No, they're not very harsh in giving marks. But there are so many persons not getting the marks. Sometimes the markers, the exam paper, a lot of persons getting things wrong. It's almost 70% of the people who do the exam fail. You know, that they see a lot of wrong things on the exam paper. So when they see you do something right, they'll give you the mark. So they don't mark hard. I can tell you that. All right? Yes? They give you the mark. I guess any format they put them in, they will give you the mark. But I think the safe thing to do, just give them back the exact same thing that they give you, just to be safe. Right? So next time you get one like this, give them back how they give it to you. Work out what they are, establish what the values are, put them back as they were given in ascending order. And note, if they said descending, then you would put the largest one first, if the question was descending. Because they can give you another question where they instead say descending instead of ascending. All right? So descending would be from the largest value down to the smallest one. All right, let's continue. This question says, Mahendra and Jay, they shared this amount of money in the ratio of 7 to 5. How much more money does Mahendra receive? Now, I think most persons will work this out as said, the total part in this ratio is 12. One person is getting 7/12 of the figure. And the other person is getting 5/12 of the figure. And then the difference is the amount more is the difference. But understand that? I think most persons will do it that way. And just subtract them. But this is the one that got more. This is the one that got less. And then you just subtract the figure. This is supposed to be a 4. All right? Now there are multiple ways to do it. I'm going to do it this way to do. Because I might have done it another way next time. But in fact, let me do it another way. So I think most persons will do it this way, but I'm going to do it another way, just because there are some other questions you might need to learn to extend the ratio that is given. All right? Sometimes you have to extend the ratio that is given. But what it is that sometimes they give you the difference figure and they're asking you for the original figure. So the answer for this would basically be, take this one, so this is the amount that the larger one, minus, this is the smaller one. Put the dollar sign on it and work it out. That will give you the answer, right? But I'm going to do it a different way. So if you did it that way, no problem. So the way I'm going to do it is that I'm going to show you how you extend the ratio to bring in the total and the difference. All right? So let's set up like this. Mahendra to J. J are in the ratio 7 to 5. I'm going to extend the ratio to show the total But I'm also going to extend it to show the difference. Because the question is asking me about difference. Right total part is 2. 2. And the total is 722. So what I want to represent is extend these values to represent the actual values. So if I want 12 to become this actual value, what do I multiply it by? To know what I multiply it by, I can divide by the 12. So if I divide by the 12, that's 7224. Divided by the 12, I'm going to get 602. It means that if I multiply this ratio by 602, this will become what the values actually are. So this is going to become what the values actually are, what the total actually is. 7224. And so this now is going to become what the difference is when I multiply it by 2. Multiply this by 2, I'm going to see what the difference is. So that is 602 times 2. And this is 1204. So this is actually the answer, you know. That's the amount more. If you wanted to see the actual amount that they received, they multiply this one by the 602 and multiply this one by the 602 as well. But we don't need that. So the answer is that this amount was received more. We're now showing the actual. So the answer is 1204. So if you did the other way, this should be your answer. You all got that? All right. So if you did the other way and got that same answer, no problem. So as I said, most persons would have worked out 7 over 12 of this, then work out 5 over 12 of this same figure, and then subtract them to know the amount that one got more. All right, but I just want to show you that you can also extend the ratio to show additional information. All right. It says the present population of Portsmouth is 550,000. It is expected that this population will increase by 42%. Remember, guys, when you increase something by 42%, the new figure is 142%. If you decrease something by 10%, the new figure is 90% of what it was. If you increase something by 10%, the new figure is 110%. So you don't need to work out the 42% first. All we know is that the new figure is going to be 142% of what it was before. So we can do it that way to be very efficient. It's only 1 mark for the question, and you don't want to be doing too much stuff. First part, well, not that part. The only is what asking for it. Here's asking us first to write this in standard form. So we have this number that we want in standard form. 55000. Standard form is when the decimal point is here. We want the decimal point there. It must be one place after the first non-zero digit. So the decimal point originally is at the end. And we want to get it here. So we have to divide by 1, 2, 3, 4, 5. To get it there, we have to divide by 10 to the 5th power. I will divide it by moving the decimal point 5 places back, so that will be divided by 10 to the power 5. To cancel this division of 10 to the power 5, we go and multiply the number now by the same 10 to the 5. This calculation will move the decimal point to where we want it. All right? 1, 2, 3, 4, 5. So the final answer is 5.5 times this, 10 to the 5th power. And note, a big number is going to carry a positive on the power. A small number will carry the negative on the power, like 0.00 something will carry negative on the power. You can remember that kind of stuff. So this is it, right? That is it. So anyway, you work it out, that's fine. Next question says, calculate the expected population in 2030. Remember, it's going to increase by 42%. So the new total is going to be 142%. So this calculation is just 142% times the original amount of, I put dollar sign, of 550,000. That's what we're working out. 142%. 142% times 550,000. So that is 781,000 is the new figure. If you calculated the 42% first and then add it, fine. But we need to be efficient with these percentage questions. All right, but it goes so far. All right, let's continue. The next part gives us this graph. And it says, graph below can be used to convert between US dollars and Eastern Caribbean dollars. So you have the US dollars on the y-axis, Eastern Caribbean on the x-axis. Generally speaking, once you get a graph, you need to establish the scale of the graph before you start, especially these little millimeter lines down here. So what it is, let's look at it and establish that first. What does each of these little small lines mean? All right. So here we have $1 in 5 spaces. So each space is 1 divided by 5. That is 0.2. 1 divided by 5 is 0.2. It means that each of these little millimeter lines is 0.2. All right, so you have to get the scale right before you start using it. The tendency is for person to just see this and put this as 0.1. It is actually 0.2. So we have to establish that before we start. Same thing up here. Each of those millimeter lines is 0.2. So establish that before we start. Then we're ready to use the graph now. It says convert 2 US dollars to EC. So it means that we're going to come up on the graph to 2 US dollars right here and read it across to the graph and read the EC value down. Let's see what we get. Now, this is not very clear. In the exam, it will be clear, but it's a copy, so it's not very clear. But we know that this clearly is 2 US dollars right here. So you read across to the graph for 2 US dollars till you reach the graph, and then you read it down. Looks like here to me. If I zoom in, that is 5.2, and right here is 5.4. So this is actually 5.4. And it's money, so you have to put $5.40. So it's EC $5.40. So that's the answer right here. I just read it from the graph. It's EC $5.40 is the answer. All right, that is that. And then leave these lines on the graph to show that you use the graph. So don't erase those lines. Those lines are important to say you use the graph. And this one now, 5.2, well, maybe the document not so clear, so I'll allow it. If you follow that process, that's fine. Because the document not so clear, all right? So here now, they want EC $70. But the thing is, 70 is not on the graph. To the EC scale here, 70 is not on the graph. What I suggest is that you find the amount for $7 and then multiply that by 10. But that's on that. Or you can find the amount for $10 and then multiply it by 7. But I gotta go to that because 70 is not on the graph. Right? It's a linear relationship. So you find the amount for $7 and then multiply what you get by 10. So you see here, I'm going to work with $7 here. 7 EC dollars. Up on the graph. And then read it across here. It's on this line. Not very clear. In the exam, it will be clear. Don't worry about it. Now that is 2.6. 2.6. So right here is 2.6. Which is $2.60, 2.60. All right, that's 2.6. So let's write it up now. What this basically means is that EC $7 is equal to US $2.60. But it's really $70 you want. And so all you need to do is multiply this relationship by 10. And so this becomes your EC $70 that you want to know. Multiply this by 10, it becomes US $26. $26. So $26 is the answer. If you did the 10, you'd have to multiply by 7. So if you did 10 over here, if you did for $10, come up and read it across, then you'd have to multiply the 10 by 7 to get the $70. But I think this is the easy way to do it. Yes? Huh? You use $1. Use $1 and multiply by 70. That could work as well. So somebody said they use $1 and get this right here. And they multiply it by what? By 70. You get the same $2.26. No, sorry. So maybe because of the graph. That could work as well. You could find the amount for $1, just say, and then multiply it by 70. All right. So $1 right here would have been what? $1 right here. Based on this graph, you see it not very accurate. Maybe would have been giving us this. So that looks like 0.4. We'll be getting 0.4. So $1 would be giving us 0.4. And we would have to multiply it by 70. Right? And so 0.4 times 7 would be giving us 280. 0.4 times 70 would be giving us 28. I think if you do it that way and I get the 28, that will give you your marks. The graph is clearly showing me 4 years. But maybe because it's not so clear, maybe this don't quite reach. Look here, so maybe the one don't quite reach. Here, if you zoom up on it, the one don't quite reach. We come up on one here, it don't quite reach this line. It's a little bit below it. See that? It's a little bit below it. All right. But if you do that way and that's what you get, CSEC kind of I think they give you marks. Because at least you have shown that of the process. All right, so maybe it could have been done that way as well. Many ways to do it. Many ways to do it. All right, let's continue. So if we got 28, you can take the mark. If you do it that way, I got $28 score. All right. If you did it the way you did, and you got $28, you can take the mark for it. That's what, how many marks for it? 1 mark for it. So you can get the mark for it. So count it as a mark. If you got $28 using that method. All right. Question 1 done. Hope everybody got 9 marks on question 1. Very important that you all get all the marks on question 1 in this exam. Very important. All exams. All right. A lot of free marks exist in question 1. All right. I don't think I need a calculator right now yet. Don't need it yet. This question says, Laura needs to put mesh around 2 seedbeds to protect her seedlings. Altogether, meaning total, altogether, she uses 60 meters of mesh. So the total amount is 60 meters. Let's put a box around this. This amount is important. That's the total amount of mesh that's used. And that is the length. That's total length of mesh. That is in meters. Meters is in length. That's the length of the mesh. Not the area. It's the length of the mesh. It's 60 meters. It says one seedbed. Oh, one of the seed beds is rectangular. This is a rectangular one. And the other one is a square. That is the square one. As shown in the diagram. It says the width of the rectangular bed is X. See here? The width of the rectangular bed is X. And the length of the rectangular bed is 3 times the width. That is 3X. So the length here is 3X. Let's put on the diagram. So the length here is 3X. Over here is 3X as well because it's a rectangle. And this is X, so this side is also X. Why am I putting all 4 sides? Because we're talking about length. The fencing is going all the way around the perimeter. We're going to need that. And then now it said the length of a side and a square is Y. Square bed is Y. So each side is Y. So this is Y. Then you have Y on this one, Y on this side, Y on that side. All right, so those are the dimensions of the 2 seed beds. It says, use the information given above to derive a simplified expression for y in terms of x. This means you must get a formula for y equals something something x. Y must be the subject. That's what I mean by y in terms of x. You need y alone to be the subject, all right? What is the information? The total length of the fencing is 60 meters altogether. So the length of the fencing on this plus on this is equal to 60 meters. Remember, the fencing is going around, so that's a perimeter of the two seabeds. All right, so we can set it up like this. The perimeter of the rectangular one plus the perimeter of the square one is equal to 60. We're not putting on the meters. We know that we're working in meters. What's the perimeter of the rectangular one? It's 3x plus 3x at 6x, 7x, 8x. So the perimeter of the rectangular one is 8x. But I can say that? 8x. So this is 8x. All right? Plus the perimeter of the square one is 4y. 4y. That's all equal to 60. They need y in terms of x, meaning make y the subject. This cannot be divided by 4. Let's do that first and simplify it. Divide by 4. We're going to get 2x plus y equals 15. But it's a y in terms of x. So we need to take this 2x over this side to make y alone the subject. All right. So we're going to get y equals 15 minus 2x. That's the answer for that. Y in terms of x. But we go to that. Good. So y will always be equal to 15 minus 2x. Let's continue. Next part says, the area of the rectangular seedbed is equal to the area of the square bed. So the two areas are equal. It says, use this information and your answer in part A to write down a quadratic equation in terms of x, the one x alone, and show that it simplifies to this equation. So the information is that the area of the two seabeds equal. So the rectangular seabed was at 3x by x, don't it? That was at 3x by x. And the square seabed is a y by y. The question said the area of the rectangular one is equal to the area of the square one. That's what it said. And it said must use information from the first part. Information from the first part that is that, let me put it in red, is that the y is equal to 2x, is so? Or 50 minus 2x. 50 minus 2x, right? Good. It says use this information, so let's write it down, because we're going to have to use it. 50 minus 2x. Oh, no, we're going to have to use it, because the answer here is in terms of x alone. So we're going to have to substitute away for the y somewhere. So let's put the expression here now. See, they don't give a lot of space to work. They don't give a lot of space to work. So the area of the rectangular seabed is 3x squared. So we're multiplying these two, don't it? And that is equal to the area of this one, which is y squared. But I go to that. Then now, to get the equation in terms of x alone, we're going to have to take this, what y is, and substitute it here for the y. Because we want to get an equation with y alone, with x alone, sorry. So that's what we're going to have to do. We get an equation in y alone. Then put it in a different color, what we're going to do. So we're going to take this that the y is equal to and substitute for the y right here. All right, don't have a lot of space. All right, don't have a lot of space. But what we're going to get is that 3x squared, back to the block, back to the blue. We're going to get that 3x squared is equal to 15 minus 2x all squared. And then we need to expand this out. Let me shift this around so I can have some space for the word. Let me shift this around a little bit so I can have some space for the word. So let me put this over this side. Let me put this over this side of the screen. The y relationship. Let me put it over here. Make it a little smaller. And let me Let me turn this around. Let me turn this around. Let me write it that way around. All right. So I'm going to write the area of the square. It's just for convenience I use of the space I'm doing this. All right. It's equal to the area of the rectangle. So I'm just shifting this around just for the convenience of the use of the space. So there the square is y squared equals here the rectangle is 3x squared. I was substituting for the y here again. This into this. All right, just to give us a little bit more space to work. But the space here is very small, as you can see. All right. So you see, it shows you that you have to be efficient in the exam room. So when substitute for the y, this is going to become 15 minus 2x all squared equals 3x all squared. Let me zoom up. So get this equation now. We're going to have to expand this out and simplify it to get to this equation. All right. Let me continue up here. So when we expand this thing, when we expand that thing, that's a perfect square. Remember, we're going to do the 15 squared first. First term squared. 15 squared is how much? What is 15 squared? 15 squared is 225. Then we're going to multiply these two things and double it. Remember, when you expand a perfect square, let me write it out here for you. Let me write it out here for you. When you expand a plus or even minus, let me put a minus this time. A minus b squared is equal to the first term squared, which is a squared. Then twice the product of these two things, they become minus 2 times ab. And then the second term squared is a plus b squared. That's what I'm using. So right now, this is the first term squared here. Then I need to do twice the product of the two. Means I need to multiply those two things and then double it. When I multiply this time this, I'm going to get 30x. Double 30x to 60x. So my middle term is going to become minus 60x. Then the second term squared is going to become 4x squared. And that now is what this was. And it is all now equal to the 3x squared over here. 3x squared. So when I take this 3x squared and bring it over here and subtract it from this 4x squared, I'm getting x squared. So that's how we get the x squared. Then this remains minus 60x. And this remains 225. And that's now all equal to 0. And that's what they told us to show. What good at that? What good? All right, nice. The part now says you have to solve the equation. So the same equation that we just got, we have to solve it, and they're telling us to use the quadratic formula to do it. And the bottom must know the quadratic formula by now. Minus b plus or minus square root of b squared minus 4ac all everything over 2a. Do I need to write the formula? Let me write the formula. How much space you have? Let me write this formula. Huh? It's on the formula sheet. It's on the formula sheet. So let me just solve it then. All right. So based on this, the x is gonna be minus b. The b is negative 60, right? So it's minus and negative 60. That's minus b. Plus or minus the square root of the negative 60 squared, which is same as 60 squared. And negative 60 squared and positive 60 squared is the same. So 60 squared minus 4 times a. The a is 1. Coefficient of x squared here is 1. 4 times a, the a is 1. Times c, the c is 225. 225. And remember, don't put this part alone over the 2a. It has to be everything over the 2a. The a is 1. So everything over 2 times 1. That's what we're working on. All right? And then we're going to use a calculator and just get the plus value and the minus value, both of them. Let's see what we get now. So we're going to get two values for x. X equals or x equals. Two values we're going to get. Let's look at it now. All right. Remember, you know, the mathematics must always make sense. Oftentimes with these calculations, one of the dimensions not valid. So for example, if you get one of them negative, not valid. Get one of them too small, with the calculation just don't make no sense, not valid. That's how these questions always go. Most times, one of the values can't work for some reason. So you're looking out for that. You do a lot of maths and you practice, you learn that. That's what happens a lot of the times. All right, so let's set up this equation now, or this solution. So it becomes a fraction. Now this minus 60, but just becomes a 60, right? Let's do the plus first. Plus the square root. That is 60 squared minus. Now this calculation is just going to become 4 times 225. Because the 4 times 1 here, so it's 4, right? So it's going to become 4 times 225. And you're putting that over. This 2 times 1 is a 2. That's giving me 1, 5.
Wait, sorry. Shouldn't the 60 be negative in square root?
Oh no, this is supposed to be a plus. Hold on, this is supposed to be a plus. But I was just saying, this inside here, whether I will put it negative or positive, it's still, you're gonna come out to be the same. Negative 60 squared and positive 60 squared is the same thing. So it don't make a difference on the squared value. Understand that? So that's why I didn't bother to put the negative. It don't make a difference there. Because it's b squared.
Sir,
Whether b is positive or negative, it don't make a difference. All right, good. All right. So let me erase this. All right, so the calculation is giving me 55.9, call it 56. 55.98, that's 56. I'm getting 56 as one answer. And the other answer with the minus, I'm getting 4. Let's call that 4. 4.019. Let's just call that 4. Let's just simply call it 4. All right? Remember, these are distances in meters. Now, remember, we want to see if this makes sense. Remember, this is the formula for y up here. 50 minus 2x. Look what happens now. If you put 56 for the x inside here, you see that you're going to get a negative y? What I can say that? So the 56 is too large for the x. See that? It's just too big. 56 is too big. And if you think of the area that you're working with, the area is just going to be too big. So this 56 will cause us to have a negative y value. And therefore, the 56 is not valid because it's going to cause the y value to be negative. And the y value is a distance. Length of distance can be negative. But I understand that. So that's why this answer is not valid. This is not a valid value. Don't make any sense. So this one is not valid. So this is the one that we're going to be using as our answer for the distance. But understand that. For the 56 is causing us to have a negative y value. All right? And down here now it says calculate the total area of the 2 seedbeds. To get the total area of the 2 seedbeds, we just need to calculate the area of 1 and multiply it by 2. All right? And since we have x, we know what the value of x. We're not going to waste time and calculate the value of y. We don't need it. One of the seedbed was just 3x squared, don't it? That's all? Good. And the two of them is the same, right? So the area, total area, becomes equal to 2 times 3x squared, the area of one of the seedbeds. And the two of them was the same. That's why I'm multiplying by 2. So it becomes 2 times 3 times 4 squared. What I work out? This is 16. 16 times 3 is 48. 48 times 2 is 96. That's what 96. That's right. That look like 96. 2 times 3 times 16. Yeah, 96. The 96 is what? Meters. And we put the unit in there, guys. Meters, we're working in meters, right? Yeah, 60 meters. You put the meter squared on this. Everything important. 96 meters squared is the answer. But I go to that. So if you learn from this kind of question, when you get this distance question, the length of something and area and so on, you cannot accept an answer where the length of something is negative. So even though you got this positive, you look and see what to do to make the y. To make the y negative. Because if you had calculated the y first, you would have got the negative value of y. Just have calculated x first. In some other question, you might have gotten a positive and a negative x. You have to ignore the negative one. But distance cannot be negative, all right? All right, good. Let's continue. Number 3. This question says, a flagpole PF stands on horizontal ground and is a vertical flagpole on horizontal ground. So the angle between vertical and horizontal is 90. That's why that is 90 degrees. So we're working with some right angle triangle. That's a right angle triangle and a right angle triangle. It means that we can use so-called tower and we can also use Pythagoras' theorem when we're working right angle triangle. There's no need for sine rule and cosine rule in right angle triangles. So-called tower and Pythagoras' theorem, good enough. All right, so the vertical flagpole is held by 2 ropes, PG and PR. So PR and PG is holding this vertical flagpole. You want to kind of visualize what they're talking about. We can visualize and bring it to real life. Sometimes you can interpret and understand the question better. We can visualize what they're talking about, right? It says PG is 18 meters. That's this length, it's 18 meters. And while I'm reading here, guys, I'm checking the diagram to see if everything that they have said is on the diagram. Once everything that they have said is on the diagram, it means that I don't need to go back and read anything up here. I just work from the diagram, right? FR is 9.7 down here, that's on the diagram. And the angle inside here is 38 degrees. So everything that they have said is on the diagram, so I can just work from the diagram now. It says calculate the height of the flagpole. That's this height I want. To calculate that height, we're going to work in this triangle, but that is the triangle that we have the most information. Males, what they're doing? Look a boy. So we have this angle and we have this hypotenuse. We're working in this right angle triangle. And this is the opposite to the angle, right? And this is the hypotenuse. So we're using so-called tower, opposite and hypotenuse that are connected with the sine trig ratio. So we're going to say sine of the 38 degrees, start with the definition of sine, is equal to the opposite side, which is the FP that we want, over the hypotenuse, which is 18. We can just put in the values. Then to make FP the subject, we're going to take this 18 and multiply it up here in front of the sine of 38. All right? So we're going to get that the FP comes equal to 18 times the sine of 38 degrees. And I will do this calculation, and we can write the answer down here for FP. Let's calculate it. Anybody did that can just tell me? Anybody did that?
11.1.
11.1 to 3 significant figures. All right, good. 3 significant figures, 11.1. Is it meters? Yes, meters. The distances are meters, yes, because of flagpole and so on. It can be centimeters. All right. So what we like to do sometimes, as you calculate something, you put it on the diagram, because sometimes it helps you and shows you what you need to do next. So this height is 11.1 meters. So put it on the diagram. So we know that in this triangle now we have 2 sides, and we can use Pythagoras' theorem now to find that side. Because that's a right angle triangle now. It says find P and find PR, the length of one of the pieces of rope used to hold the flagpole. That's this one over here. I want us to find this length over here now, PR. So we're going to use Pythagoras' theorem, and that's a hypotenuse, right? So we can just write it like this. You can just write it like this. Everybody must know Pythagoras' theorem. The PR becomes the square root of the 11.1 squared and then 9.7 squared. That's Pythagoras' theorem. You can just use it. You're free to just use it like that. All right? And that is it. But anybody use it and got the right answer? Anybody did that?
Yes, sir.
What was the answer? 14.73. So I'm going to put 14.7. 3 significant figures. Make sure you put your meters as well. All right? Beautiful. Next question. Oh, that one done. All right, this one says, in the diagram below, PQ is parallel to MN. Let's mark it. So these two lines are parallel lines. Now, once you have parallel lines, there are some angles that you're looking for now. Looking for Z angles, which are alternate angles. You're looking for co-interior angles that we call U angles. You're looking for corresponding angles. You're looking for vertically opposite angles. Let me give you some examples before we start. Once you have parallel lines. So for example, what is that? What would be a Z? Like for example, here. This along this one, down this one, and then back along this one. That will form a Z. So these two angles equal. They are alternate angles. Z angles. It form out a Z. Then we have co-interior angles now. Watch this now. So if we come along this one, come down this side, and then go back along this way, it's like we have formed a U. The angles in the base of the U are called co-interior angles. They add up to 180 degrees. The two of them add up to 180 degrees. They total 180 degrees. Both of them. Co-interior angles. That's an example of co-interior angles. Let me show you corresponding angles now. So corresponding angles is like you have this transversal line now crossing those two parallel lines. That transversal line is going to make the same angle with the two lines. So for example, this angle up here, X, on top of the line with that parallel line is going to be equal to this one down here. Those are what we call corresponding angles. They correspond to one another. They are equal. And then you have a thing that we call vertically opposite angles now. And that's like angles on an X. So you're looking out for it again. So it's like you have that line. Let me show you, of course, I'm going to show you the X. Let me show you the X. Yeah, the tablet's going up. So like you have this. Let me put back this one in red. I'll show you. So it's like you have these two now. Right? You have an X right there. So it's like these two angles now are vertical opposites. The angle over here on these two and the angle over here on those two, they are equal. Vertically opposite. You can look at the other end as well. These two angles are equal. Vertical. Once you have an X like that, these two angles equal and these two angles equal. They are called vertical opposite angles. So those are some of the things you look for once you start having like parallel lines and transversal lines and so on. This is called a transversal line because it crosses these two parallel lines. It's called a transversal line. All right, enough information. Let's answer the question. So this one says you have to find the value of X. Find the value of X. The question also told us that we have an isosceles triangle. Let's finish it. It said that this triangle, LRT, this one, they say it is isosceles. So clearly it is these two sides that are equal in length, don't it? So it means that these two angles are equal angles. But you can say that? All right, let's populate the diagram and leave it on the screen. So these two angles equal. And in an isosceles triangle, once you know one angle, you're blessed. You can find the others, right? So these two angles will be equal to 180 minus the 28 divided by 2, because those two angles are the same, right? So it will be 180 degrees minus 28 degrees divided by 2. That's going to give us that angle that I'm pointing to. What that work out to? How much? 76 degrees. So it means that this angle inside here is 76. I'm gonna mark it better. So I'm just gonna point to it like this. So this is 76. And this is also 76 because of the isosceles triangle. And I'm leaving this calculation on my paper to show the examiner how I got that, right? And then now remember the one x, right? Multiple ways to find x. So we know that this angle is x. So this angle is also x, don't it? Corresponding. Okay, use total angle and straight line right here is 180 degrees. So the x becomes 180 minus 76. Somebody can say that? That's not the only way to do it. But that becomes it. We could also do this as well. Watch this another way we could do it. We could say this angle here is a z angle. And so this angle in here is 28. So we could say this angle is 28 degrees right here. And then now, these two angles equal. These two angles, this angle over here, in these two lines, is equal to the sum of these two angles. So it's also equal to 76 plus 28, the x. All right? Well, let's use a straight line and do it. Multiple ways to do it, guys. Multiple ways to do it. I'm going to use a straight line down here and just say the x becomes 180 minus 76. What do I work out to? 104 degrees. 104. So x is 104. Notice I'm not putting the degree on it. Why am I not putting the degree on it? Because the question gave us x degrees. So the value x is just 104. The angle is 104 degrees, but the x is 104. All right? That is that. What are you going to say for me? Go outside. Never see a three per chance yet. That is it, 104. All right? That's the value of x. Oh, that is it? That's all I wanted? Okay. I said we could have done it this way as well, right? 76 plus thing. So let's put it here. So, or we could use a z angle and do x equals 76 plus 28. Using the vertical opposite angle. That's going to still give us the 104. And I'm certain there are still other ways to do it. All right? But that's good enough. All right, let's continue. 2 marks for that. So this question gives us this diagram as a transformation. Diagram below shows a shape T and its image Q after a transformation. So this is your object. This is your image. So the transformation is from this one to this one. You're going this way with the transformation. All right? And that looks to me, when looking at it, looks like a reflection on sight. But oftentimes a reflection and a rotation can look the same. And to make the distinction, sometimes you check the orientation just to confirm. It's not an enlargement because there's no change in size, and it's not a translation because the thing clearly changed position, right? Or change its orientation then, or change, it rotates, some rotation took place. All right, it turned, it's not the same. Translation, there's no change of anything, just position, right? So let's double check if it's a reflection. If it's a reflection, the orientation will be reversed. So all we need to do is name a couple sides, vertices, I mean. So for example, here I'm going to call it A, call this B, and call down here so C. And on this image, this will correspond to the A, that will be A prime. This will correspond to the B, that will be B prime. This will correspond to the C, that will be C prime. The orientation on this one is clockwise, A to B to C. Over here, the orientation is that way, anti-clockwise, A to B to C. So the orientation is reversed. Once the orientation is reversed, you know that you have a reflection in a line. Reflection in a line reverses orientation. Maybe reflection obviously, but there are some questions where they can look alike. A reflection and rotation can look alike. I need to basically make that distinction sometimes. Now, the mirror line is going to be halfway between them, between corresponding points. So, for example, these two corresponding points, the mirror line is going to be somewhere here. And between these two corresponding points, The mirror line is going to be here. So basically, this is the mirror line. You know? The mirror line is right down the middle here. So. Right down the middle of the graph. You can clearly see. It's very obvious to the naked eye. And that line that passes through the origin and through the points where the x and the y value is the same is the line y equals x. So if you're describing it, you have to state that line. That's what I wanted to do here. Describe the transformation. It's a reflection in the line y equals x. You cannot just say a reflection. If all you say is a reflection, you're not getting the marks. You have to give the name and the components of the describing. If you're describing a reflection, you must state the mirror line. So it's a reflection in the line y equals x. A reflection in the line y equals x. So I give the name and the one component, which is the line, the mirror line. That is it. Huh? No, it's not a rotation, but I just showed you. See, so you have to do that check that I just showed you a while ago. Oftentimes, a reflection and a rotation can look alike. Right? To make it clear what I am trying to bring at it is check the orientation. If the orientation is reversed, then it's a reflection you have. Just think of yourself looking in a mirror. You look in a mirror, your right hand looks like your left hand in the mirror. And vice versa. So the orientation is reversed. That's what mirrors do. So transformation, reflection, transformation reverses orientation, reflection in a line. Oftentimes, a reflection and a rotation can look alike. You can see a reflection and believe it's a rotation. To make sure, just to double check, just test the orientation as I just did. Put on a couple corresponding points and check the orientation on the two of them. If the orientation was the same, they could say yes, it's a rotation, and you could go figure out the rotation. But once the orientation is reversed from clockwise to anti-clockwise or anti-clockwise to clockwise, you know you have a reflection in a line. Reflection in a line is the only transformation that reverses orientation. All right? Good. All right. Next question says, on the diagram above, we have to draw the image of shape T after it undergoes a translation by this vector. This vector -1, 6 means 1 to the left, that's -1, and then 6 up. That's how it's going to move. 1 to the left, 6 up. That's what this does. First value is the horizontal movement. Second value is the vertical movement. And we're doing it on T. So we're going to do a translation on this one. And all we have to do really is do the translation with 1 point first and then draw the shape around that 1 point. All right? Let's throw it in purple. So let's say we're doing this point. We want to see where this point goes. With the 1 to the left, 6 up. And then we'll just draw at the same shape around that 1 point. We don't have to do all the points. So when 1 to the left, check the unit. This is 1 unit. That's 1 unit to the left here. 6 units up. 1, 2, 3, 4, 5, 6. I could count it from 1 up to 7, 6. So this point is coming here. Let me put it in blue. This point is coming right here. So all I need to know is draw back this shape around that point. What do I mean? This length, for example, was 3 units. So the image is going to be 3 units on here as well. 3 units to there. This side is 2 units up. So that's going to be 2 units up. This top piece is 1 unit across, 1 unit across. And then this diagonal closes or completes the shape. So complete the shape. That's our image. Let's say label it M. So let's put an M on it for the examiner to see. That is it. But I go to that. So this was 1 to the left, 6 up. Want to give it to your graph, you can just count it off. You don't have to calculate it. It can be done by calculation as well. We get on a graph, just count it off. Easy. But okay with that? Online? Body online okay with that?
Yes, sir.
Yes, sir.
All right. Good. All right. 9 marks on that question. Next one, number 4. The number 4 is a coordinate geometry. It says a rectangle PQRS has a diagonal PR where P is this point. So that is the point P, -3, 10. Let's write it out. And R is this point, 4, -4. R is a point 4, -4. First part wants us to tell them the length of the line. Remember, the formula for the length of a line in coordinate geometry is like Pythagoras theorem. Square root of the difference in the x value squared plus the difference in the y value squared. It comes from Pythagoras theorem. So the length of the line, PR, is equal to square root. Difference in the two x values squared. So this x value minus this x value. You're subtracting them. So it's 4 minus, and this x value is a -3. You have to be careful. That's a square. That really becomes 4 plus 3. And I can subtract in any direction. If I go the other way, it will be -3 minus 4 squared. If I subtract them the other way, which will be -7 squared, same as +7 squared. Then I'm doing the y now. Difference of the y. These are the two y values, this and this. Subtract them. That's -4 minus 10. This is the y value here, minus, this is the y value there. And you're squaring that as well. That's the calculation that you do it. So this works out to be the square root. This becomes 7 squared. Plus, this is -14 squared, which is the same as 14 squared. -14 squared and 14 squared is the same. This is what you're calculating. Whatever I get for that now is the answer. All right? Let me see what it is. I'm going to leave it with the square root over it. Let me see what I get. I'm going to put the word units because it's the length. Coordinate geometry is measured in units. So the square root of 7 squared plus 14 squared. And it's 15.6, but you can get an exact value, maybe, which is this. 7 root 5. 7 root 5. I'm going to put 7 root 5. 7 root 5 units. That's the exact value. You have to round up in it. That's what the calculator gives. 7 root 5. All right? That is it. That's the length of it. Next part now wants the equation of the line. To find the equation of a line, we need to know 2 things about it. We need to know the gradient and a point. A gradient and any one point will give you the equation. And because it is points that we have, we can use the point gradient form for the equation of a line. Remember, you also have the intercept gradient form, which is y equals mx plus c. Doesn't matter which one you want to use. So I'm going to use the point P. I'm going to use the point P as my point. I can maybe use the R and show you that the answer is going to be the same as well. -3, 10. I'm going to use this as my point. But I also need to know the gradient. Gradient M. Remember, gradient is rise over run. The rise is the difference in the two y values. That's what the rise is. Remember, when you take in the rise, the direction you go for the difference in the y values, you must go the same direction for the difference in the x values. It's very important when calculating gradient. So if I'm using this y value to minus this y value that way, then when I'm doing the difference in the x for the run, I have to use this x value minus this x value that way. So I'm subtracting it this direction, the R point minus the P point. Let's set it up. So it's the y's, rise is the difference in the y value. This y value minus this y value. That's -4 is that y value minus this y value is 10. Divided by this x value minus this x value. That is 4 minus this x value is -3. You have to be careful. That becomes a plus. This reduces to -14. -14, that becomes a +7. That is now a -2. So the gradient of the line we want is -2, and the line passes through this point. We're going to use the point gradient form. So the equation that we're going to use is y minus the y value at the point equals the gradient into x minus the x value at the point. That will give us the equation straight. If you want to use y plus mx plus c and then plug the values in there to find the c, some people do it that way, no problem. But this will give you the equation straight. Let's set it up. So it's y minus the y value at the point is 10. So it's y minus 10 equals the gradient is -2. -2 into x minus x value at the point is this -3. So it's x minus -3. This becomes a plus. Let's put a little red plus there so we don't forget. It becomes a plus. So this reduces to y minus 10 equals, this time this is -2x. Then this is -2 times a +3. That gives you -6. Then this -10 comes over and becomes a +10. +10 minus 6 gives me 4. So it's y equals -2x plus 4. If you get this equation some other way, that's fine. Let's do it with the other point just to show that it would work as well. Let me reduce the size of this. And just do it with the other point, R, just to show that it would work and give it the same answer. All right, let me do it here. So if you're using the point R, the result is going to be the same. So I'm going to say I'm using the point R. And R had coordinates 4, -4. 4, -4. So it's an OR method now. It will be y minus the y value at R equals the gradient into x minus the x value at R. Must get the same equation. So it's y minus y value at R is -4. So it's y minus -4. That becomes a plus. This minus minus a plus. Let's put a plus there. Equals the gradient is the same -2. -2 into x minus x value at R. The x value at R is this 4. That's a 4. Then it becomes y plus 4. Here becomes y plus 4 equals -2 times x is -2x. -2 times -4 give me +8. Then this 4 comes over and subtract from that 8 to give me 4 again. So it will be y equals -2x plus. So you get the same thing with the other point. We don't need to do it both ways in the exam, guys. Just use one of the points. All right. And if you use the C method, that's okay as well. Once you get this correct answer, that is it. Very good. All right. Everybody got that answer? You got it? All right. Beautiful. Nice. Let's continue. 3 marks for that. 3 marks for that. Now come to functions. That's a functions question. All right. This is f of x. This is g of x. That's a square. It says all it means that in this function, we're going to change this to x minus 2. That's all. Now we have a value there. We're going to put a function. Make the same substitution. No problem. So this is just equal to 3 times where the x is I'm putting the x minus 2 and then this plus 1. That is it. And then so must simplify. This expands out into 3x. 3 times that is -6. -6 plus 1 is -5. But I understand that. But I go to that. 3x minus 5 is the answer for that one. Next part. They want g of 3x plus 2. Let's write what g of x is up here. G of x, remember, is x squared. All right. Yes, x squared. So g of 3x plus 2 means I want to put 3x plus 2 where the x is. And then we have to add this 10. All right. So this thing becomes equal to 3x plus 2 squared. That's what the g of x is, this thing, the g of 3x plus 2, plus this 10. But understand that? What about that? Because the g of 3x plus 2 means I put the 3x plus 2 in this, where the x is, and that's how we get that. And then this plus 10 now is added to the result. And we need to simplify this now. We're going to expand this perfect square. Remember, it is the first term squared, which is 9x squared. Then twice the product of the 2 means you multiply these two things first. You're going to get 6x and then you double it with 12x. You're going to get plus 12x for your middle term. Then the second term squared over here is a 4. 2 squared is 4. And then you add back this 10 out here, so now. So this is just expansion of that. Let me underline it so we can see. So this expanded out to this in red. And now we're adding the 4 and the 10 now. You get the final answer. So it becomes equal to 9x squared plus 12x plus 14. That is it. Anybody got that? What? You're bright, man. You're bright.
Yes,
Very
sir.
good. Beautiful, beautiful. All right. 2 marks for that. That finishes another question. Let's continue. Next question says, Mr. Morgan administered a spelling test to his class. The table below shows the number of words out of 10 that each student spelled correctly. So this is the data, guys. You have to know your data and your frequency. That's the data. So this is like your X. And this is the frequency. That's like your F. Remember, your scores are data values. So like mean, mode, median, range, interquartile range are of these values. Get me? The number of words are your score values. All right? So you have to make note of that. All right. Question says, for the data shown in the table, what is the mode? The mode is the value that the score that occurred most frequently, the one with the highest frequency. See the highest frequency here? Don't write 8. The answer is not the frequency. The score that corresponds to the highest frequency is this 5. So the answer is 5. Hold on. I'm going to call it. Yeah, to the call now. Let me tell you my name. All right. So the mode is 5, guys. 5. So the mode equals 5. But you can understand that the mode is 5 words. One that occurred most frequently. 5 words. So the mode is not 8. The mode is a score that corresponds to the highest frequency. 8 is the highest frequency. The score that corresponds to the highest frequency is 5. 5 words. Next one, the median. The median. So the median is the score in the middle of a distribution when it is in ascending order. Such a young lady there. Hello, ma'am. Can't sleep and learn nothing. Such a young man there. Oh, I'm doing it today. Wanna sleep at night time? You don't want to sleep, go outside. No sleeping inside here. All right. So the median. So the median, remember now, is the score in the middle of the distribution. Mute the mic, please. The score in the middle of the distribution is the median. So we need to find where the middle of the distribution is. So basically then, we need to know how many scores we have by adding up the frequency. So add up these to know how many scores we have. So we can know which score is in the middle. So when we add up these, what do we get? Add them up for me, what you get? 23. So that 23 is the total, right? 23 total. So that is the n. The number of scores is 23. So n equals 23. So if you have 23 values, the one in the middle is going to be the 12th value. Can you see that? Like you divide the 23 by 2. So you have 11.1 end and 11 on the other end. So the value in the middle of 23 value will be the 12th value. You can reason that out. If you can't reason it out, we have a formula way to do it. Remember the formula way? The position of Q2. Remember the median is Q2 is half of the n plus 1 term. Half of the n plus 1 term. The n is 23. So this becomes half of 24, which is the 12th term. You see it? That's right. The 12th term. So the 12th term is your median. Your 12th term. So you're counting the term now in the frequency. And you're counting it in the ascending direction, this way. This way, this way. The ascending direction. So you start out with 8 values there. Remember, you have 8 5s. Remember, you're looking for the 12th value. You have 8 5s already. Then after the 8 5s, there are 4 6s. So you reach 12 values right there, so the 12th value is a 6. But can see that? So your 12th value is a 6. So we have 8 values first, then 4 more. So your 12th value is the last of this. The 12th term is right here. So your 12th term is a 6. So the median equals 6. So the Q2, which is the median, is equal to 6 words. That's the answer. But go to that. 1 mark. But okay. All right, beautiful. So to them ask for the first quartile, you would do 1/4 of n plus 1, right? They ask for the upper quartile, it will be 3/4 of n plus 1. That's the position of it. And you count the frequency again, same way until you reach the value that you want, right? Count the frequency. When you count the frequency, you're counting how many values you have as you go from score to score. Find the value that you want. All right, let's continue. Next one says, calculate the mean number of words. So the mean number of words now, you're going to basically add up all the words, all the number of words that were correct, and divide by the number of students, which is 20. Right? So basically, let's look at it. It's like 8 persons got 5 words. So that's 8 times 5. You're doing 8 times 5, plus 4 times 6, plus 2 times 7, plus 2 times 8, plus 3 times 9, plus 4 times 10 to get the total number of words correct. Divided by the number of students. That is the mean number of words correct. But that's not a calculation. All right. So I'm writing it down here because I just want to do it on the screen and copy it down. So the mean will be equal to 8 times 5 words. That's 8 times 5. Plus, then you have 4 times 6 words. 4 times 6. Then you have 2 times 7 words. 2 times 7. Then you have 2 times 8 words. 2 times 8. Then you have 3 times 9 words. 3 times 9. Then you have 4 times 10 words. 4 times 10. I divide that by the total number of words. Total number of persons was 23. You know the average that each student got, the average number of words were 23. 23 total frequency. All right. So that's the number of students. So this is the calculation that gives you the mean. But understand that that's the sum of the words. Sum of f divided by sum of fx divided by sum of f. Now what we did here now, up here, what it did up here was the sum of fx. Remember the mean is the sum of fx divided by the sum of f. So up here is the sum of fx that we just did. And this is the sum of f, sum of the frequency. So this is what gives you the mean. Sum of fx divided by the sum of f gives you the mean. All right, so I'm copying this down now. I'm putting it in this place that it's supposed to be. So still come over here. The line didn't come. But can't tell me that work out to? 7. 7
Yes, sir.
words.
7.
All right, good. 7 words. I'm write the formula here in red, so it's on the screen. So the mean is the sum of fx, that's the sum of the sum, divided by the sum of the frequency, the number of values. That is it. 7 words. All right. Is the mean number of words, correct? All right, cumulative frequency graph now. This question says, the attendance officer at a particular school recorded the time in minutes taken by each student in a group to travel to school. The data collected is shown in the cumulative frequency curve below. So the number of students right here is 220, don't it? Remember now, these are the students up here. This is the time that they travel to school. But remember, the cumulative frequency graph, it don't really give you actual time. It give you a less than time or less than or equal to time. Sometimes at the start, you read the question, you know which one the graph is showing. Is that it's going to show less than time or less than or equal to time. So it's going to show you how many students travel less than or equal to any given time. Down here, right? Remember, the students who travel the shortest time are at the bottom. Students who travel the longest time are the ones at the top. All right, so the students are in ascending order for the ones who took the shortest time up to the ones who took the longest time. All right, let's see what it says now. It says using the cumulative frequency graph. To use the graph, you have to draw lines on the graph, show lines on the graph to show that you use the graph. We're estimating the number of students who took at most 32 minutes. Now, this term at most means that 32 is the most. So it means less than or equal to 32 minutes. That's what it means. So it looks like we have a less than or equal graph. This graph is giving us less than or equal to time. We always want to establish that from the get-go. It's giving us less than or equal to time. It's telling us how many students took less than or equal to any given time. I want to know how many took less than or equal to 32, because at most 32 means 32 or less. Not going past 32. Don't let the word most cause you to think that you're going over. Look at the meaning of the term. All right? So we're looking for 32 on here. And remember, when I read the scale of the graph, I'm careful. So here now, we have 10 units over 5 intervals. So it's 10 divided by 5 is 2. So it means that each of those little small units here is 2. Let's put it there. This is 2, so don't forget. Then on the y-axis, we have 20. And again, there are 5 units. 1, 2, 3, 4, 5. So it's 20 students in those 5 little millimeters. So it means that each of these is 4. So put that on the graph so you don't forget it. Each of those little millimeter mark is 4. You have to always get the scale of your graph before you start to read anything from it. All right, get the scale first. All right, so we're coming to 32. So 32 is going to be right here, but I can't say that. That's 32. And then read up on the graph and see what 32 gives you. And whatever I give you, don't adjust anything. So what the graph is showing you, how many students got less than 32 or took less than 32. So come on the graph. Looks like right in between here to me, you know. Looks like right in between here to me. Right there. That's what it looks like to me. Remember, on your paper, it might be not so clear. Let's count it now. That's 40. Remember, each line is 4, right? That's 44, 48. That's 52. This should be 56. So right in between here, so is 54, don't it? Right between 52 and 56 is 54. What can I agree with that? 54. Good. Now, if you do it on your paper, you get 55 or 52 or 56. If you get 52 or 56, fine. I might have gotten 52, I might have gotten 56 based on the paper that you were working with. Not so clear. All right? But based on this, my graph, when I zoom in, I'm seeing 54. So I'm going to work with the 54. All right? I'm going to work with 54. So I'm going to just write 54 down here. 54 students. 54 students. All right? Let's just double check and make sure. Remember, this is 40, 44, 48, 48. Let's make sure. After 48, 4 more is 52, 4 more is 56, and 4 more is 60, right? And we're right in between the 52 and the 56. So we're working with the 54. All right, we accept 54, just to make sure. So it's 54 students. Let's continue. 1 mark for that. 1 mark for that. Then the one interquartile range. Interquartile range, remember, is Q3 minus Q1. So we're going to have to find each of them. Q3 minus Q1. All right? All right. Now, remember, the position of Q3 is what? 3/4 of the 220 students. That's all. The position. And the position of Q1, is 1/4 of the 220 students. We're working on the position down here. So somebody wrote this out for me. 1/4 of this and 3/4 of that. What's positions? 165, that's 156 students. And over here, that's a position, you know. Over here is what? 55. All right. So looking for this 165 student. That's what we're looking for those quarters. Let's go now. So looking for what we said, 55 and 165. This one is the position of Q1. This one is Q3. All right. Let's do Q1 first. 55. Wow, 55 and 52, 54 almost are the same, you know. This and this are almost the same, you know, because what will happen is because remember the scale is so narrow. 55, you might want to put 55 here. 55. I'm going to put the 55 there. So this is my 55 right here. I'm going to just 54 that we had before. That's my 55, right between the 54 and the 56. It's almost the same place. Almost the same. It's almost the same. It's just right on the right of this. Same. So we can literally give about the same value. This was 32. This was 32. This was 34. I'm not going to give it 33. Let's give this 33. Or 32.5. I mean, just an estimate. See, they use the word estimate, guys. See, estimate. Everything we're doing here is estimating. So I'm going to give this 33. So I'm going to say Q1 is 33 minutes. Now we're going for 165 now. 165. Let's find 165. So this is 160. 170 will be right here. All right, let's work it out. 160. 164. This is 168. 168. That's 164. So 165 is going to be right in between here. So right here is 166. So we're talking about around here is 165. What a question. I mean, easy, man. So this is my 165 right here. Take this out. That's right, 165. So come across on the graph. Use a straight line, come across on the graph till they reach the graph. Looks like we're on this line right here. Let's see where it goes down to. Do it with your ruler, guys. Don't do it friendly like me. Do it with your ruler, please. Right down to here. That's 54, right? Remember, every millimeter is 2. So this right here says 54. So Q3 is 54 minutes. So interquartile becomes 54 minus 33, right? Good. 54 minus 33. So I'm writing equals 54 minus 33. What that work out to? 21 minutes is the interquartile range. If you get something close to that, like 20, 21, 22, you say your graph not so clear, that's fine. All right, so that's what we're getting. Remember, we're estimating, you know, guys. So they'll accept the answer what that they get. Trust me. 2 marks for that. Next question. All right, so this is what I want to spend a little bit of time on. And maybe ask a couple additional questions on this, right? For this question. It says, the letters in the word positivity are each written on separate cards and placed in a bag. Dacia picks 2 of these cards at random, and this says with replacement. So with replacement means that she's putting the cards back in the bag. Without replacement would mean that she's not putting the cards back in the bag. And there's a difference in the result. If you put the cards back in the bag, then the probability of the second dip is independent of the first dip, because it's going to be the same as it was if you put the cards back. If you take the cards out and don't put it back, then you're changing the sample size that is in the bag. And so the second dip depends on the first dip. And so that will be dependent events. So independent events are events where one don't affect the other. Dependent events are events where one affects the other. You get me? So example, another example, a good example of independent events is like flipping a coin. If you flip a coin one time, the probability of getting a head or a tail is half. If you take the coin and you flip it again, the probability of getting a head or a tail is still a half, it's not changing. So the flipping the coin 2 times, a first time and a second time, will be independent event. And what you get on the second try does not, it's not affected on the first try. All right? So because they're putting back the thing, we basically now have independent events. Because what is happening is that by putting it back, you're putting back the sample size, or you're putting back the sample space, right? So the probability remains the same. I'm going to do an example without with this one and see what the result will change, just in case. So this one says I want to get a what? I want to get the eye, right? So there are 3 eyes in it. How many in all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 3 eyes in it. Now, so to get an eye, and then I get an eye again, the probability of getting an eye then an eye, or an eye followed by an eye, you're going to multiply the probabilities. That's what you do. So when you have combined events like that, one followed by the next, you multiply the probabilities. So there's a rule that says, and you multiply or you add. So if you want the probability of something happening or something else happening, you add the individual probabilities, or you add the probabilities and you multiply the probabilities. Simple rule like that. All right? I'm going to have a session this week where we spend some time on it, some more time on it. It's probability thing. But generally speaking, it's on the most known sheet that I gave you. Or you add the probability. So if you have event A or event B happening, it's the probability of A plus the probability of B. That is if it is or. If you want the probability of A and B happening, then you multiply the probability of A by the probability of B. Especially when they're independent events, eh? Huh? No, this is going to multiply them. So this is going to multiply them. So probability of getting an I first, because it's then the probability of getting an I first is 3 out of 10. That's the first one. Times probability of getting an I again is another 3 out of 10. Why is it 3 out of 10? Because it was replaced. It was replaced. So probably getting an I first. It's 3 out of 10. And then when I get out the I, then put the I back in the bag. So you still have 10 in the bag to get an I out of it again. So the second time is still 3 out of 10. You multiply them. So the answer is 9 out of 100. That is the answer. 9 out of 100 is the answer. If it was without replacement, look, if it was without replacement, what would happen? Without replacement. If the question instead said without replacement up here, right? I should have put it in bold letters for you. If it was without replacement, then when you take out the first I, the probability of getting the first I would be 3 out of 10. Remember the I come out now and it's not going back in the now. So you only have now 2 I's out of 9. So to get the second I to be 2 out of 9. You understand that? This is the probability of getting the first one times the probability of getting the second one. And if you're going out for a third I, that will be equal to what? Without replacement. That will be 1 out of 8. And you multiply them. That will be the probability of getting 3 I's without replacement. Yes? Yeah? Oh, it's not 2 I's. The I and a V. Okay. I just give an example 2. I remember I want to discuss this a little bit. So I'm doing an example of getting 2 I's for here. We're going to do the actual question afterwards. So this will be 9 over 100 for 2 I's. I'm just using the I's as an example. You get me? With replacement versus getting the 2 I's without replacement. That will be it. You get me? We're going to do the I and the V with replacement and without replacement as well. So let's do the correct answer for this now, which is the I and the V. So if it was an I and a V as it is here, probably getting an I first with replacement would be 3 out of 10 times the probability of getting a V. Remember the one that came out here is put back in the bag, you know. How many V's you have? Just 1. So that will be 1 out of 10. So this answer will be 3 out of 100. So this is the actual answer for the question. Getting an I and then a V. No, this is the with replacement. Look at it again. Just think of it. So imagine that you took out the I first. This is the probability of taking out the I first. This 3 out of 10. But you're gonna put it in back. So when you put it in back, you're gonna have 10 in the back again to take out the V. You see that? Youngster, I don't know what I'm talking to. One player, man. You understand? So you take the I out the bag. That's the probability of taking out an I. 3 out of 10. We're going to put it back. It says with replacement. So when you put it back, the second draw, you're going to be drawing from 10 again in the bag. And it's 1 V in there. I'm just doing this now for the I and the V. Because the V only has 1 V in it. That's why it is 1 out of 10. It can apply to any one of the letters. This question was asked for I and V. So if we were doing, look, if we were doing the I and the V down here without replacement, let's do the I and the V. Probability of an I, then a V. But this time we're doing it without replacement. So you're not putting it back. Wait, no man, we are wasting time. What? Listen. You need to listen. Okay? Just listen. Listen. Let's go again. So we want to get that I on the first try. When we get out that I, the probable chance of getting out that I is 3 out of 10. So I think of you getting out that I. The chance of getting out that I is 3 out of 10. There are 3 I's in the bag, and the chance of getting out 1 is 3 out of 10. With replacement. So if you get out the I, you're going to put it back in the bag. And you're going to draw again. So you still now have 10 in the bag. But this time you want a chance of getting a V on the second try. So the chance of getting a V on the second try, which is what we're multiplying here, is only 1 V in the bag. So it becomes 1 out of 10. still for the second draw. So this is the combined result of getting an I and then a V. The chance of getting an I on the first draw and then a V on the second draw with replacement. Listen to the without replacement now and make the connection. If we're doing the I and then the V without replacement, meaning that we're not putting back in the bag after we do the first draw. The chance of getting an I on the first draw is 3 out of 10. For all 10 in the bag, and there are 3 I's. We're not putting in back anything. So the second draw now, you're going to only have 9 in the bag. Remember, one of the I come out already, you know. One out of the I come out already, you know. So you only have 1 V in the bag now, but there are 9 left in the bag. So the chance of getting a V on the second draw is 1 out of 9. Understand that now? So you multiply this now by the probability of the second draw being a V is 1 out of 9 that is left in the bag. 1 V out of the 9 total letters left in the bag. That's a combined probability without replacement. You understand it now? Still understand it? All right, guys. We can't do this today. We could do this in another week. All right, we could do this in another week. So this would work out to be 3 over 90 without replacement. This will be 3 out of 90 without replacement. Anybody else have a problem understanding this? Huh? But good? I can look out for a question, guys, where they say without replacement. And that's what you do. Without replacement means that you're not putting in back the first draw. Just imagine that you draw a first draw, the first draw is an I. Chance of getting an I on the first draw is 3 out of 10. But there are 3 I's and 10 total letters in the bag. And get all the I. The I gone. You know, have 9 letters left in the bag. 2 I's in there. So if you want another I, that would now be 2 out of 9. But if you want a V, that's going to be 1 out of 9. There's just only 1 V in the bag. You're imagining that you took out the I already with the 3 out of 10 probability, and the I come out of the bag. So you have reduced the total number of letters in the bag to 9. Okay, you're not putting it back. Without replacement means you're not putting it back. So one of the I's will be gone. So if we're going to get an I again, that would now be 2 out of 9. The chance of getting another I will be 2 out of 9. We're kind of putting it back. But it's a V1, so that will be 1 out of 9. It's a V1. It's not complicated, guys. Sometimes what happens to us is that we think of it too deep. It's not very deep. It's just obvious. They usually just one. Usually just one. Draw one, replace one. They have probability question where you're taking out 2, and they ask you, what's the chance of taking out this one followed by 2 things and so on. They have different scenarios. But we're gonna deal with it in the week. All right. And in fact, there's another one on the paper today. We're gonna explore that one a little bit more again. All right, but let us move from this one. So the actual answer for this one is 3 out of 100, guys. With replacement, 3 out of 100. All right, remember, if they ask a question for the same question, right? The first draw. So what's the probability of getting a? So ask what's the probability of getting an I or a V on the first draw. So ask for the probability of getting an I or a V on the first draw. It means that you want to get any one of these 4. So it's 4 out of 10. So that's why we say, or you add the probability. If you want an I or a V, it means that is 4 possibilities you have. Any one of the 4 you get. So that will be 4 out of 10 of getting an I or a V. If you look at it probability-wise, the probability of getting an I is 3 out of 10. It's become probability of getting an I plus probability of getting a V. Probability of getting an I will be 3 out of 10 plus probability of getting a V will be 1 out of 10. That gives you the 4 out of 10. That's what I say, or you're adding, or you're combining what you want to get with the or. So, or you add and you multiply. Generally, that's how these things go. Just work with that for the time being until we understand more. 6, you're not going to ask anything more than that, really. All right? But there's another question on the next paper we're doing today. I want to talk about that one a little bit more. We'll get to that. All right, let's move on. Spend a lot of time on this one. Number 6. This question says, diagram below shows a gold bar in the shape of a trapezoidal prism. Its volume is this. That's the volume of that prism. It says the length and height of the prism are indicated. This is the length of the prism. The distance between the two ends. These are the two ends. Remember, this is the cross-sectional area of the prism. So over on this end, you'd have the same shape. Like so. Over this end. Same shape. So the cross-sectional area is this shaded area here. Remember, for prisms, volume is equal to end area times length. The cross-sectional area is the area here. The length is always the distance between the two ends. So this is your L. That is your L. Good. Question is asks us to calculate the area shaded, which is the cross-sectional area. It is the A in this formula. So we divide by the length to get the A. So if you look at this formula, you want to find the A, you divide by the length. So we can write that the end area, cross-sectional area, is the volume divided by the length. Simple as that. The volume is 2886 divided by the length, which is 31.2. Whatever you get for that calculation is the answer. This is the length. What do you get for this? 92.5, and it is centimeter squared. But I got that? Beautiful. Beautiful. Next one. It says the cuboid shape of gold bar shown below has the same volume as the trapezoid. So the volume of this is also, what is it? 2886 cm cube. All right, same the cuboid. It says the height of the cuboid is h, and that's what they want us to calculate. So the volume of this cuboid will be length times the width times the height. Just work it out that way, don't it? All right, and we're going to equate that to this figure. So it's the 30.6 times the 8.2 times the height, that is equal to this volume of 2886. So to find the height, we're going to take these two and divide it under here. Same kind of calculation. So 8 equals 2886 divided by the 30.6 and the 8.2. Whatever that work out to, you're going to put it in centimeter. What do you work out to? 11.5 centimeters. All right, good. 2 marks for doing that, you know. 2 marks for doing that. These are like giveaway questions. Next one. It says the trapezoidal gold bar is melted down and all the gold is used to make 6. They put 6 in capital letters, so you can't miss it. 6 identical spheres. Remember, a sphere is like a ball, right? A ball, like a globe, circular. Right? Like a marble. Right? It's a sphere. It says calculate for each sphere the radius. All right. So what do we know is going to preserve? Volume is going to preserve. The total volume of the bar is now going to be the total volume of the 6 identical spheres. The volume of one sphere is this. This formula is the volume for one sphere. And the 6 of them you have that is now equal to the volume that was there before. So see here now, when I say 6 times the volume of a sphere is equal to the volume of the bar that we had before. But understand that 6 times the volume of a sphere is equal to the volume of the bar. So we can actually divide by the 6 here if we want, right? And we can say 6 times the volume of a sphere is this. 4/3. Then some must use pi as 22/7 times r cubed. We did a question like this yesterday. And that's all equal to the volume of the bar, which was 2886. But that's not a calculation. 6 times the volume of a sphere, which is 4/3 This is the pi r cube, and we're trying to find the r. We did a question like this yesterday. So we're going to transpose everything away from the r. Yeah? That's, you can do that if you want, by dividing by 6. No problem, same difference. But we can calculate this straight from here, so still. So I'm going to take this 3 times 7 and multiply it up here. So I'm going to get 3 times 7 times, I could put 21 if I want, times 2886. That's this going up here. I'm going to take this 6 and this 4 under here, divide by the 6 and the 4. That leaves me the r cube. And to get rid of that cube, I'm going to cube root this thing. Oh, I'm going to move the 27 yet. I'm going to take this, or 7 gone. I need to move the 22. The 22 is coming under here as well. Times 22. And r cube equals that. To get rid of the cube, I'm going to cube root this side and then remove the cube from here. So the r becomes equal to cube root of that. But understand that? Transpose this. But understand that? Just transpose the values. So we do that calculation, we're going to get the r, which is what they want. Cube root of that. Transpose, just transpose, transpose. All right, so it becomes the cube root of a fraction. It's 3 times 7 times 2886 over 6 times 4 times 22. I'm getting 4.86. 4.86 centimeters. Anybody got that? All right, good. So if we do it another way and got the same answer, no problem. 4.86. Next one wants the area of a sphere. That's the formula for the area of a sphere. 4 pi r squared. So the area becomes 4 times pi, which is 22 over 7, times this radius squared, times 4.86 squared. That's going to give you your answer. All right, so it's 4 times 22 over 7. All right, 77. 22 over 7 times 4.86 squared. I'm getting 296.9, call it 297. 297, that's area, centimeters squared. 1 mark for that. But I got that? I don't get that. Huh? That's what I got? Four pi r squared. 4 times pi is 22 over 7. And the radius is 4.8. What did you use for your radius? Yeah, that's right. You don't get a little light about it, but that's okay. That's why I always tell you guys, practice 3 significant figures. Please practice 3 significant figures. Practice to give your answer to 3 significant figures when the answer is not exact. All right, 3 significant figures is the standard. All right, next question. It says the mass to the nearest kilogram means you don't put in the decimal, nearest whole number you want. The nearest kilogram means that you're going to put the nearest whole number. Given that the density of gold is this. All this means, guys, not complicated. All this means that 1 cm cube is equivalent to 19.3 grams. All right. And how much gold do we have? We have 2886, don't it? We have 2886 cm cube. That's the total that we have, right? So we just need to multiply this by the 2886. All right. So the mass becomes 2886 times the 19.3. grams. Huh? Yeah, man, it's mass one. Mass equal the density times the volume. You multiply them. Look, if 1 cm cube is this amount of gold in grams, then you have to get this amount, you multiply it by the same 19.3. The other one, they wanted it to the mass. What? Oh, they want for the sphere. Oh, it's for the sphere they want. Okay, my mistake. They want for the sphere, not for the whole thing. So the volume of the sphere, you're right, you're right. The volume of the sphere was 2886 divided by 6. Is the sphere they wanted for? You are correct. It says for each sphere. It's what we're talking now. For each sphere. So the sphere you wanted for, right? So it's 2886 divided by 6. That's correct. All right. So it's 2886 divided by 6. It's for the sphere. That's 481. Could divide by 6 as well. 481 cm cube. So you multiply here by that. The mass of a sphere is 481. I was calculating for the whole bar. The mass of a sphere. So what we get for that? 481 times 19.3. 8802.3 grams. And 1 to the nearest kilograms, so you divide by 1,000. That's 9 kilograms to the nearest kilogram, right? So you could do this. You could do 8.802 kilograms. So you put 9. Huh? Where? On the calculator? Oh, my mistake. All right. 19.3. All right, good. All right, so that's 9283.3, which is 9.2833 kilograms, which is 9 kilograms to the nearest kilogram. All right. All right, that question done. Next question. So everybody got that, right? All right, this is a pattern question. This one gives us this sequence of regular hexagons. Each regular hexagon is made using sticks of unit length. Complete the diagram below, represent diagram 5. Okay. So let's see what does that mean. So it is like they're adding a pair of hexagon on top of this one, right? From shape to shape. So I'm going to draw this one and just copy it down. So this is what is added to each shape. So I'm going to copy this down as I can and put it on, I'm supposed to put it on top here for the next shape. On top here for the next one. But it's down here, we have to put it. On this one. Where is it? Oh, but we have to fill up these spaces first. We have to fill up this space first. And fill up this space first. Like it gets smaller. So. And then put another one on it. Let's change this a little bigger. I'm using up the device, guys, because I can. So filling out these first. That was missing, right? Fill out those that was missing. Erase these. Fill out those two that was missing. And then adding this additional one. to here. Let me change this one to a different color first. That's where the diagram is supposed to look. So the red is what you're adding. Let me see. Yes, the red is what you're adding, and the blue is the additional piece to make it figure diagram 5. But go to that. All right, good. So the red was missing, right? It's like they took out the red pieces, and they have to make figure diagram 5 other than the blue. So that is it. All right, next question. The next part says, what is the table, right? H is the number of sticks, S the perimeter of each figure, P each figure P follow a pattern. So the values for H, S, and P for the first 4 diagrams are shown in the table below. Study the pattern, and then we have to complete the rules for these figures. All right. So we want to study the pattern. So this is the diameter number, number of hexagon, number of sticks, perimeter. All right. All right. Perimeter of the shape. Let's fill out. So as usual, we like to fill out this line first when we can by observing the change in the numbers. So here they're increasing by 2, right? So they're increasing by 2. 2n starts the formula. So 2n starts the formula because it's increasing by 2. The first figure, however, has 3 in it. 2 times 1 is 2. We have to add 1 to the formula to make it work. Here, they're increasing by what? 8. That's a plus 8. That's a plus 8 again. That's a plus 8 again, right? So they're adding 8 each time. So 8n starts the formula. Gotta keep adding 8. But the first figure actually has 15 in it. 8 times 1 is 8. You have to add 7 to make it 15. So it's 8n plus 7. Over here, about thing 2, increasing by 4. Increasing by 4. So 4n starts the formula. It's increasing by 4 from shape to shape. So it starts with 4n. But the first figure has 12 in it. 4 times 1 is 4. We have to add 8 to make it 12, right? So it's 4n plus 8 is the formula. All right, so ready now. For this row weight is 5. We're going to take 5 and drop it on here. 2, 5 is 10 plus 1 make 11. Or it is the next shape, so we could just add another 2 to make this 11. Here we can add another 4, don't it? No, add another 8, sorry. That's a plus 8 column, right? Or you can take the 5, drop it on the formula, get 40 plus 7 is 47. And we want to look at it. This is 47. This is worked out for us already, 28. Then this is 47 now. To get the figure for here, what we're going to do is equate the 47 to this formula and work out the n. All right? So let's do that. So over here, we're going to write that the 2n plus 1 is equal to this 47. Subtract the 1, 47. So we're talking, please. Subtract the 1, we get 46. 46 divided by 2 is 23. So n equals 23. So right here is 23. And if n is 23, we can take the 23 and drop it on this formula and work out this one. How much you get? 100 flat. Because it becomes 4 times 23 plus 8. That's 100. All right, that's done. 1 mark for each answer. 1 mark for each answer. 7 mark total. Next part says, Skylar says she can make one figure where the perimeter is exactly 1005. Explain why she's incorrect. What usually happens with these questions is that the n must be a counting number, natural number. And any shape that will cause the n not to be a counting number, they can't make it. All you have to do is put the formula equals this for the perimeter, and if the n is not a natural number, means that it can make. So let's make a statement that the n has to be a member of natural counting numbers. That's what this n stands for. The n has to be a counting number. So we're gonna try the formula for the perimeter. P, the perimeter is talking about. So that's the perimeter. Try the perimeter equals this. Try to see if 4n plus 8 can be equal to 1005 and give you a natural number. If you don't get a natural number, then she is not correct. So if we work this out now, subtract the 8 and then divide the 4, right? So the n would be equal to 1005 minus the 8 and then divide by the 4. And what do we get for that? 249.25, which is the 249.25 is not a member of the set of natural numbers. Therefore, she is not correct. That the n has to be a natural number. She is not correct. That is it. But go to that. Online, everybody okay?
Yes, sir.
All right. Hope everybody reached 100 marks. No, 100. We have about 30 more, much more, 45 more marks to get. Much marks? Is that 12 marks for each question zone? 12. In section 2. You have 36 more marks to get. What's this question look so long? Yeah, 12 marks for each question. 3 more questions. We could just run through these quickly. We can get a break to another paper. All right. This question says, f and g, another functions question. This one is f, this one is g. So we have to find g of 2. So we're going to put 2 in the g function right there. Simply going to become 5 minus 2 squared. This 2 squared is 4. 5 minus 4 is 1. That's like a free mark in section 2. Next question. F to the minus 1 of 3. You can do this by finding f to the minus 1 of x first. We can also use the method where we put it equals some number n. Put it equals some number n. And if f to the minus 1 of 3 is n, it means that 3 is equal to f of n. I won't find n, we have the answer. Now f of n now is we put in n in the f function. So it means that 3 would be equal to 2n minus 1 over 3. Still gonna have a transpose. And then we're trying to find the n from this. Or get n from this. Over 3. This time this over here says 9 first equals 2n minus 1. Then bring over the 1 and add it. And divide by the 2. So the n equals 9 plus 1 over 2. So the n equals 5. So the answer is 5. So therefore, f to the minus 1 of 3 is equal to 5. That's the answer. If you do it the way we find f to the minus 1 of x first and then plug in the 3, that's fine. That works as well. But that's a nice quick way to do it. All right. Next question. Derive an expression for this composite function. Remember, f of g means to put in the g into the f. G into f. Let's copy them down and show how we make that construction. So the f is 2x minus 1 over 3. And the g is 5 minus x squared. Let's copy them down. Stop talking, please. Stop talking, please. Hey, I'm going to send on someone going out to the class and I'm going to send you guys home. All right. So put f into put the g into the f by taking all of the g and bring it and put it in the F where X is. That's what I put G into F. So it means that F of G of X becomes, we're setting up this construct, we're constructing that substitution. So it becomes 2 bracket 5 minus X squared where the X was, minus back this 1, and you're putting that all over 3. Let's stop talking, man. I'm running home now. Then this reduces to 2, 5 is 10. 2 times minus X squared is minus 2X squared, minus this 1, all over 3. 10 minus 1 is 9, minus 2X squared, all over 3. That's leaving it like that. All right, that is it. Next one. This question says, oh, we have to sketch a graph. Sketch a graph of G of X. The space provided below says on your sketch you have to integrate maximum or minimum. Remember, G of X is what again? 5 minus X squared, right? So you know it's going to have a maximum. Voice gone. 5 minus X squared, right? And I want us also to show the roots. The roots are the points of the graph intersect x-axis, right? So we need to know where the turning point on this is. Now, how we can show the turning point on this, you see? Is to get it in the standard form, in the vertex form, I mean. Get it in this form. G of X equals A into X minus XT squared plus YT. Get it in that form. XT, YT is going to be the turning point. It's not difficult. I'm just showing you something. Let me do it down here. So the G of X is going to be minus X squared plus 5. Why did I do that? I want to get the X term in front. All right. See this X squared, because it's just X squared, there's no X term there. I'm going to write minus X minus 0 squared plus 5. Because remember, I'm trying to get it in a vertex form like this. It means that this is the X value at the turning point. This is the Y value at the turning point. And it's a maximum turning point. So the maximum point is actually 0, 5. Good? The first thing. Remember, the roots is when you put the set up the equation. Put the expression equals 0. So we're going to do the roots in purple. So for the roots, we're going to graph intersect the x-axis. We put in the expression equals 0. Remember, this expression is same as 5 minus X squared. So it's minus X squared plus 5 equals 0. Then X squared moved away, you get positive X squared. So you have X squared equals 5. So it means that X equals plus or minus the square root of 5. What's the square root of 5? Square root of 5 is about 2.2 or something like that. Let me see. What's square root of 5 again? 2.1. 2.23. All right, let's put 2.2. So this is plus or minus 2.24, you say? All right, let's write 2.2. Guys, just a sketching, still a sketching now. But just have to give us a graph, so we want to kind of get the accuracy on it, right? If you notice, they're not putting a scale for us. They're not putting a scale for us, so we're going to have to put some scale on it. What's marks for this? 3 marks. Yeah, so we're going to put some work. All right, so we need 0, 5 to the maximum. So we can go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our maximum is right up here. And then we can actually get a couple points as well, you know, because we should have a couple points based on some stuff that we calculated up here. G of 2, for example. Remember, G of 2 was 1. That's a point, and that's a point, 2, 1, you know. That's a 0.21, for example. All right. So we can actually get a couple points on this thing. All right. So we're gonna put 1, 2, 3. 1, 2, 3, -1, -2, -3. So I'm making the x-axis a little wider. And this is -1, -2, -3, -4, minus. I'm actually gonna just draw the graph accurately. So, all right. So it passes through 1, 2. Can I see? Remember, this function is same as 5 minus x squared. So if you take 1 and plug it in there, so you get 5 minus 1 is 4, right? So it pass through 1, 4 right here. So 1, 4. Let's put on some points. And put -1 in there, you're gonna get the same thing. 1, 4 over here. So they will put in 2 in here. Get 5 minus 2 squared is 4. So you get 2, 1 that we did before. 2, 1 is right here. And also -2, 1 there. And then we have the 2 roots. Remember, we have the 2 roots. We cut the x-axis, but let's put in 3 first. So put in 3 in there. Put 3 in there, so we're gonna get 5 minus 9. 3 squared is 9. 5 minus 9 is -4. So we'll get -1, -2, -3, -4 is on this line. We'll get a point down here. Just do it and done. And over here. So the graph pass through those points, guys. Just get a couple points quickly from this equation. You can see it quickly. And just draw the curve like this. And like that. Kind of makes sense because I give you the graph of the 3 marks. And these 2 are the roots. Let's show the roots. These are the 2 x values that were calculated. These. Let's put them on in red. Or in purple. So this point is your 2.23 or 2.24. So we're working with 2.2, right? That's one root. 2.2. That's a root. And the other root over here is -2.2. -2.2 is the other root right here. Those are the 2 points where the graph intersect the x-axis. The roots. That's what the question wanted us to show. The roots. And also asks for the maximum point, right? This point is the maximum point. It asks for the maximum point. So I'm going to indicate that this is a maximum point. Maximum point is 0.5. So give them everything. So they can't take off any marks for that. Give them more than the ask for. But they give a graph, you cannot draw it accurate. Use a plain paper, then fine. But give a graph, try to get it accurate and done. You get me? Just plot a couple points, pick up and draw. You don't have to plot the points, as I just did. I just show you how we could relate the vertex form to get to show you the way the maximum point is. I'm sure you could use this and just plug the x values in there and get the points, as I just did. So for example, put in x equals 0, you get the 5. See that? They get 0.5. So you could just plot some points, as I just did, to get those points. Just put the x values in this and get the y values and put them on the graph. Get me? Good. That is it, guys. That is it. This next one. It says the graph below shows a quadratic function. This is a quadratic function. All right, what it says, on the grid above, draw the tangent to the curve x equals 1. Here is x equals 1. On the graph, x equals 1 is this point. So this is the point where they want the tangent right here. Right here, put it in blue. On the graph, x is equal to 1 at that point right there. They want a tangent at that point. So on the actual paper, you would have to use your ruler and line up your ruler against the line like this, against the graph like this. Line up your ruler like this against it. That's how you line up your ruler, right? So that your ruler just touching the point there. And you line it up right so that it just touch there. Don't let it cross, such that right at this point, the ruler and the graph coincide. And you line it up like that. And when you line it up like that, against the edge of the ruler here now, you're going to draw that tangent line down here, passing through the point. right against the ruler. Like that. But you understand that? That is the tangent line against the ruler. That's what you're all gonna do. Huh? Yeah, man, you want to see, especially across the x-axis, draw it long. So that is a tangent line. It's supposed to be a straight line, guys. Don't draw it wibbly wobbly like me. Use your ruler and draw it straight. And it must just touch the curve alone at a single point only. Now, based on this, looks like it passed through this point to me. I'm sure if you do it on a graph paper, it's going to pass through this point for real. That point is -1. This is the tangent line. This red line is a tangent. Tangent at x equals 1. X equals 1 on the graph is this point. And that's the tangent at x equals. You have to draw it straight with your ruler, please. So if you line up the ruler against the graph, that is something we have done in the class, right? Remember the day we come out, we did some of them, right? Good. And then you find 2 points on the graph, on the line, to find the gradient. So we're using this point and this point to find the gradient. Any 2 points we can use to find the gradient. And again, because we have the graph, we can count out the rise and count out the run. So I've done the first part, which is to draw the graph, the line, and here now they want us to use the tangent to get the gradient of a curve. Remember that at this point, the curve and the tangent have the same gradient. So the gradient of a curve at that point is equal to the gradient of a tangent at that point. So we need to find the gradient of a tangent. Remember we did the topic called gradient of a curve, and we use a tangent to the curve method to do it. So the tangent passes through these 2 points. Let's write it out. Gradient of a curve equals gradient of a tangent. Let's write it. Gradient of the curve at x equals 1 equals gradient of the tangent at x equals 1. I'm going to use these 2 points to do it. Okay, I'm counting the rise and I'm counting the run. Okay, let's count it off. So from this point to this point, what is the rise? 1, 1, 2, 3, 4 is the rise. And you over here says 1 and no guys. So it's not counting squares and you're counting the units. So the rise is 4 units. 1, 2, 3, 4 units. But the run is just 1 unit across here. See it? 1. So the run is 1 unit. This is 1, 2, 3, 4, 5 squares or 4 squares. But the 4 squares correspond to this 1 unit out here. So the run is 1 unit. And the rise is 4 units. So that is the rise. And this is the run between those 2 points. See that? There's 1 unit. See there? 1 unit is 4 centimeters to 1 unit is the scale on the x-axis. On the y-axis is 1 centimeter to 1 unit. 1 square to 1 unit. 4 squares to 1 unit horizontally. But this out here is still 1 unit of run. Okay, coming out to a unit of 1. 1 unit. Then that's a matter of just counting the squares. You're looking for the units. So the rise is 4 units, the run is 1 unit. See that? 4 over 1. So the gradient is 4 over 1. So rise over run, which is 4 over 1. 4 is the answer. 2 marks for that. Anybody here got 4? Anybody got 4? You draw the tangent? Use x equals 1. Which one? Which one you use x equals 1? You draw a tangent here. You have to find another point on the tangent. You have to find another point on the tangent and use 2 points on the tangent to get the gradient. That's what you have to do. After you draw the tangent, the question even telling you, say, use a tangent. Use a tangent. All right. So if you get one like this again, you make sure you get it. Yes, mom? Did you follow this process? You need to do it over and do it the right way for me, please. All of you need to redo this question and do it the right way, please. Redo the question and do it the right way, please. All right, let's go. I don't know the equation of course. I can't calculate the correct exact answer, suppose, but that's what I'm getting from this drawing. But that is the process you must follow. Now, if you follow the right process and you draw your tangent a little bit lean and it causes you get a different answer, and you give the CXE what your answer, you follow the right process, you will get the marks still. And not everybody gonna draw this tangent exactly the same way. That's what I'm saying. Not everybody gonna draw this red line the same way. But also what they CXE just want to see that you're following the right process. You try to draw a tangent the right way. Your tangent must not cross the graph. You must not see any space between your tangent and the curve. The tangent must appear to just touch the curve only at this point. Just touch it. That's how it must look. You must not see any space between the tangent and the curve. It must just appear to touch the curve only at that point. That's what a tangent does. A tangent touches a curve at a single point only. That's what you're trying to do. All right? Let's continue. It says, write down the equation of a tangent. So the gradient is 4, and it passes through -1. Anybody can see that? So my gradient is 4, and my C is -1. See, that's something to write down. No calculation needed. Y equals 4x minus 1. That's it. So why you need to extend the tangent, my boss. So you pass right through the graph. They can see we cut the y-axis. All right, beautiful, beautiful. Next one. This question says, V, X, Y, and Z lie on the circumference of a circle. Drawn below, center O, the diameter is VY. So that's a diameter right here. Remember, angle subtended by a diameter is 90 degrees. So this angle here is 90 degrees, subtended by that diameter. All right, let's see what else it says. It says UW is a tangent at the point V. And the angle VXZ is 62 degrees right here. And this angle is 18 degrees right there. All right, that's what it says now. It says, state the theorem that justifies the value of each of the following angles. You see it? This question is forcing you to write the rules. So you have to know them. You see it? You have to know them. You can't just have a question where you're writing the answers and not putting in the rules. You have to know to write the rules. All right. What angle? What angle is 62? Angle B is 62. Angle B is this one. Angle B is subtended. If you come back to the reach circumference, it is subtended by this chord that I'm marking out in red. And that same chord is subtending this angle at the circumference at 62. So that is the same segment rule. These two angles are in the same segment of a circle. Both of them are subtended by that red chord. So they are equal. Angles in the same segment are equal when they are subtended by the same chord. That's what we're going to write here. Angles in the same segment are equal. Angles in the same segment are equal. If you stop there, get the marks in them. If you want to finish it, you're going to say, when subtended by the same chord. It can be an arc as well. Same chord or same arc. Remember, arc can also subtend an angle. So this will be the arc subtending the two angles as the same. This will be the arc. This red arc is subtending those two angles as well. See that? That red arc. An angle can be subtended by an arc or by a chord. All right? So they are equal. Same segment. That's why these two angles are equal. Next one. That angle is 124. Angle C is 124. Where is it now? Where's C? C is right here. 124. Now that's an angle at the center, subtended by the same chord that is subtending 62 at the circumference. That's the center rule. Angle at center is twice angle at circumference. So C is 2 times that. Angle at center is twice angle at circumference. It's 2 times 62. So this angle C, I'm going to write it out. It is 2 times 62 degrees. I'm writing it like that. I'm going to write out the rule now. Angle at center is always twice angle at circumference. So those who think they're not going to learn the rules, see question forcing you to write the rules here now. See it? It's not about just calculating the angles. You have to know to write the rules, practice them. At circumference. Circumference. If you write just that, you get your marks. Angle at center is twice angle at circumference. We can continue and say when subtended by the same chord or arc. Same thing again. Chord or arc and something and that's it. But God, you have to know the rules and you have to know to write them. Been doing this from before this year start, and we now reach April. End of April. Next one. This angle is 90 degrees. That's angle OVW. Let's see where that is now. Angle OVW. OVW is 90 degrees. That one easy. Tangent and radius. Good. Angle between a tangent and a radius is 90 degrees. Angle between a tangent and a radius is 90 degrees. That's right. Angle between tangent and radius is 90 degrees at the point of contact. At the point of contact. Now, if you stop right here, where the angle is 90 degrees, I think they give you a mark. We just write that alone. Angle between tangent and chord is 90 degrees. I think you get the one mark if you just write that. But if you want to be sure, just add in this part as well. At the point of contact. It's 90 degrees at the point of contact. Next one. It says find the value of each of the following A, D, and E show working. So this now they're not asking for the rules. No, this one show working. Oh, you get them, right? Just basically calculating them. A first. Let's see what angle A is and so we can calculate. A. All right. So angle A. Angle A going to be 62. Anybody can see that? Tangent and chord, right? Angle between this tangent. Angle between this tangent and this chord means that the chord is going to subtend the same angle at the circumference. So this angle here equals this angle here. Angle between a tangent and a chord is such that the chord itself will go and subtend the same angle at circumference. So that angle is 62 degrees, right? A is 62 degrees. Tangent and chord. A equals 62 degrees. Then I'm asking us for the reasoning. 62 degrees. So can I write it still? Angle between tangent and chord equals angle, this means angle, subtended, this means subtended by the chord. Next one, angle D. Let's look at the diagram for angle D. Now we should be putting in all those angles. I will find them and I don't know if they need them. Angle D now is right here. But angle D kind of easy because remember we know C already, right? don't it? And this triangle is an isosceles triangle, don't it? What was C again? C was 124, right? So since C is 124, then this angle D becomes 180 degrees minus 124 degrees divided by 2, right? Because these two angles are the same. So what does it work out to?
28.
180. Huh?
28.
How much?
28.
28 degrees. Another 28 degrees. Another way we could find it is, since we know the A, we could say that this angle is 90 degrees, right? And this angle becomes 90 minus the A, right? And then them two are equal. We're gonna get the 28 same, right? 90 minus the 8. The A was what? The A was 62. So it also can be 90 minus 62. Anyway, you want to look at it, it is 28 degrees. So 180 minus 124 divided by 2. 180 degrees minus 124 degrees divided by 2, 28 degrees. And then the one E next. E, let's see E now. We're gonna get E. E is which angle? E is right here. All right, we're gonna get that one now. E. E. All right. All right. All right. We're gonna get E. All right, can I look at this triangle right here? Can I look at this total triangle right here? Total angle in that triangle is 180. We know so right here says 28. All right, here says 28. So these three angles add up to 180. You can use that method. All right, I know that I see that method already. Let me look if there's another way. That's one way to get it, right? Because the only thing that is missing from these three angles that added up to 180 is this E. So add up all these numbers and subtract from 180, we're gonna get the E. Let's see if there's another way. Let's see.
Wait, sir, what about the chord that like YX angles in the same segment?
Which one? This angle E.
Yes, sir. Like the 18, like you would connect an imaginary chord at YX.
This 18 here, so.
Yeah, yes, sir.
All right. Subtended by this arc. But that arc is subtending this angle up here. That angle up here is subtending here. So this is 18 and this is 18. Both of them subtended by this arc. So that's not gonna give it to us straight. That's not gonna give it to us straight. I see a way to do it already. I was looking if there's a shorter way to get it. So that's not gonna give it to us straight. I think it's this total triangle we have to work in. We can say I'm subtended by a diameter here, so it's 90. No, all right, no, let me use the total triangle here, eh? Not waste any more time. I want to work with this triangle here. Draw it in red. Let's work with this triangle. Total angle in that triangle is 180. All right, and this right here says 28 degrees, as I said, and this is 28. But let's add it up. So it's gonna be that the E plus 28 over here, E plus 28 plus this 28 plus 18 plus 28 plus 18 plus this 62 plus 62 is equal to 180 degrees. That is it. That is it. That is it. I've left off the degrees because the E has the degree on it. So the E becomes the add up all of these and subtract from 180. Add up all of these some of these. What is add up to? Add up those for me and subtract the 80.
136.
136.
136. So the E equals 34.
Oh,
44.
44, sir.
All right, good. So I was looking for a short another way, but let's see. So I'm going to work with that. Sure, there's another way. I'm just not seeing it right now. So copy this down and put it down here. Total angle in the triangle. There's one. Oh, it's 3 marks for that one. Each of them is 1 mark. Okay. All right, that is it. E equals 45. And angle E. So put the degree on it times the angle E. All right, that is it. Next question. Diagram below shows a quadrilateral PQRS formed by joining 2 triangles, PQS and QRS, 2 triangles. None of them are right angles, so we can use sine rule and cosine rule in there. Hey, I don't want any eating in there because I'm going to leave a lot of mess in the classroom yesterday. I don't clean up off on the second one. Both sides are eat. All right. It says calculate the length of QR right here. This is QR over here. When I work in this triangle, I use cosine rule. But I said that cosine rule. So we have 2 sides and an angle between. Let's set it up. Remember, cosine rule starts like Pythagoras' theorem. So this side squared, QR squared equals this side squared plus this side squared. 16 squared plus 18 squared. If it was Pythagoras' theorem, that's where it stop, but it's not. So you have to subtract a piece. You're subtracting twice the product of those 2 pieces times the cosine of the 25 degrees between them. And instead of putting a square on that, we can take off the square and just square root everybody down here and get 1 calculation. But I go to that. So QR equals what? Put that in the, anybody work it out? Can tell me what it is? 7.61 meters. Just, you know, make sure. Anybody else get that? All right, good. You know, bright, you know. Hey, you guys are brilliant around here. Brilliant. Let's continue. 3 marks for that, you know. What are easy 3 marks? Wow. Next one. It says the bearing of P from S. All right, let's focus now. Let's focus now. The bearing now of P from S. Remember, bearing must be measured at the from position from P to S. They're telling us that it is 205 degrees. We need to show it on the diagram so we can see how it helps us, right? So we're going from S to P. The bearing is 205. S to P. So S to P down here, the bearing is 205. So let's show the north line at S. That's the north line at S. Let's extend it further up here. And the bearing is measured from position down to P. That's a clockwise angle down to P around here. They're telling us that is 205 degrees. That angle is 205 degrees. That's what they said, right? Put on your diagram so you can see how you use it. All right, don't just take the information. Show it on the diagram so you see how you use it. All right, so right now we can find this angle in here now by subtracting those 2. You see that? All right, if you want it. But let's continue. So put on the diagram and then we're going to answer questions now. It says find the bearing of R from S. Again, we're going now from S again. So we're going from S to R. So again, the bearing must be measured from position. We're going now to R, right? Let's see. From S to R, from the same S, going on to R. So R out here, so. And this is the S. So the angle that they want the bearing down to this direction on to R, right? From here. So it's this clockwise angle here, so they want now. Same angle so we could find. But I said that. That angle becomes the 205 minus these 2 in here. But I can see that. Good.
Yes.
Beautiful. So the bearing there is 205 minus this. Right, just so 205 minus the 25 degrees, minus 2 angles, right? That's the answer that we want down here. Let's write it. Copy this and paste it down here. What is one work out to?
I think 108%.
Good. That equals 108 degrees. All right. Next one I want now. The bearing from P to S now. Let's make a note of it. It's always at the from position we measure the bearing. So it's from P to S. Want the bearing now from P to S. Let's go back on the diagram and look what that angle is. From P to S. We can put in the 108 that we just got, just in case we need it. So inside here is 108. 108 degrees inside here. Now one from P to S. P here, so one from P up to S. Showing us some skills now with this one, right? Showing us some skills. All right. So one the bearing from here up to there. So essentially, we want the bearing of this direction. That direction. I want the bearing of this direction. That's what I want to know. PS line is this direction. I'm extending it out here for a reason. The bearing of this direction I want. That is the direction I want the bearing of. So that direction, this is the bearing, you know, right here, you know. That's the angle that I want, you know. See that? That is the angle that I want. But I can say that. That angle is simply 205 minus 180. How is 205 minus 180? But the whole of this angle around here says 180. And everything from this north line is 205. So the angle in here, which is the bearing that they want, is 205 minus 180. So this angle that they want is 205 minus 180 degrees. What does it work out to?
25, sir.
How much?
25.
25 degrees. But you put the zero on it. You put the zero on it because it's bearing, right? So let me show you the way most persons will do it. That's a nice quick way to do it, right? Because bearing is angle of a direction. The direction of P to S. Don't stop here, so from P to S. It continues up here so as well. Get me? That's the bearing of that direction, P to S. So we could find it that way. But let me show you now the way that most persons, I think, would do it. Most persons would do it like this, by coming at the from position, as we learn. From position down here. And I would draw the north line at this from position. That's what most persons would do. Draw the north line here. And I say, okay, that's the north direction at the from position. The bear we're trying to find is really this angle right here, the clockwise, right? To that direction out there. So it's really this angle you want, right? So what they would say is, okay, we want this angle, but we say that these two angles are co-interior at up to 180, and we can find this angle up here by doing 360 minus the 205, don't it? That's what most persons do. This is more work though. So it is 360 minus 205 equals how much?
155, sir.
155 degrees. And then now, because these two are co-interior and up to 180, don't it? So the one that you want in here that you really want will be 180 degrees minus that 155 degrees, which will be equal to how much? Same 25, but you put the zero on it because it's bearings. So you see the way that I showed the first was actually quicker, right? But no problem, you don't want to hear that. But that is 0, 25 degrees. I'm going to just say on the diagram, right? So I'm going to write 0, 25 degrees. I'm going to write on diagram or C diagram. C diagram. Mean my calculation is on the diagram. See the diagram. But my calculation is on the diagram. You can do that too, you know. You can put the calculation in the diagram here, put in the answer, and see, that's my diagram. These are my calculations on my diagram. Get me? That's it. All right. So I showed you 2 ways to do it. So have fun. Question done. One more to go. Easiest one of the day. Hey, it's funny, the easiest question is at the back. Hey, it's a crime not to reach question 10 in the exam, you know? Because question 10 always so easy. That is why you have to practice managing the time. Give each question a certain amount of time. Make sure you reach question 10. You get me? Give each question the allotted amount of time that I told you. That way, you will be sure to give each of these questions the 20 minutes in section 2. 10 minutes for part A, 10 minutes for part B. Because question 10 is always two topics, you know. Matrices transformation, vectors. 10 minutes for the matrices transformation, 10 minutes for the vectors. Done. All right, let's go. Question says, the determinant of this matrix is 24. Find the value of V. Easy. The determinant is 24. The determinant is equal to 24. So all we have to do is write the expression for the determinant and put it equal to 24 and solve it. Now, what's the determinant equal to? Is this first diagonal product, which is 6 times minus V, that's negative 6V, minus this second diagonal product, which is negative 10V, don't it? 5 times 2 is 10, negative 10V. Notice that we are subtracting negative 10V. That equals 24. This is where a lot of people are going to make a mistake by not putting a negative 10V there. Pay attention, don't make that mistake. This minus minus becomes a plus. So it becomes 10V minus 6V, which is 4V, equals 24. But I agree with that. So we divide by this 4, you get V equals 6. No, sir? But again, V equals 6. Woman for that.
Yes, sir.
Right. Yes. Next part says, the matrices L and M are defined as these. Evaluate each of the following. Now, on the product L times M, we need to multiply these two matrices. Let's set it up. So multiplying the 9, 5, 3, 2 with the 2, negative 4. Let's not give away marks on these. Them too easy. Equals a column vector matrix with two values. Let's look at it again. First value here is positioned in the first row and the one column. Remember, you're going to take the rows on the first matrix. Let's put a line across here with the one column. So to get this value, you multiply this first row with this one column. You multiply them. First element in the row, then the first element in the column, then second element in the row, then by the second element in the column. So we say first element times first element, second element times second element. First element times first element, second element times second element. 9 times 2 and 5 times negative 4. The 9 times 2 is 18. 5 times negative 4 is negative 20. Then this value down here is positioned in the second row and the one column. So to get it to multiply this second row by this one column, same thing again. First element times first element, second element times second element. First element times first element, second element times second element. 3 times 2 and 2 times negative 4. The 3 times 2 is 6. And the 2 times negative 4 is negative 8. And then we'll consolidate these values to get the answer right here. The 18 minus 20 is negative 2. 6 minus 8 is also negative 2. Anybody get that? Beautiful. 2 more marks. Let's go. Next one. We want the L to the minus 1. That's the inverse of L. What is L again? L is a matrix. What is it again? This one, right? 9532. 9532. L is 9532. So L to the minus 1 is 1 over the determinant of L times the adjoint of L. That's how we get the determinant, right? The inverse. So it's 1 over the determinant. The determinant is this product, first diagonal product minus the second diagonal product. First diagonal product is 9 times 2 is 18. Minus the second diagonal product is 3 times 5 is 15. And you multiply that by the adjoint. How do you form the adjoint? Interchange the elements on the first diagonal. Interchange them. So you switch around the 9 and the 2, becomes 2 and 9. Then leave the elements on the second diagonal where they are. Don't move them. Leave them where they are, but you change the sign. So this 5 stays where it is and becomes negative 5. This 3 stays where it is and becomes negative 3. This under here is just a 3, don't it? This under here is just a 3. So now dividing each of these values by the 3. No, man, finish it. I find an inverse matrix. If you're going to be using the inverse matrix in another calculation, use the one with the fraction outside for the calculation, but give them the final answer here. All right? So divide this by 3 becomes 2/3. Divide this by 3 becomes -5/3. Divide this by 3 becomes -1. Divide this by 3 becomes 3. So this is your inverse matrix. That is the answer. Anybody got that? 2 marks for that.
Yes, sir.
Beautiful. Like the sound of that. Next one. Vectors now. This question says, this vector PQ is 5, -4, and a point P is 0, 2. No, it's -2, 0. Watch this now. If P is -2, 0, P is -2, 0, it automatically means that the vector OP, position vector of P, is -2, 3 like that. -2, 3 like that. Good? The question wants to determine the coordinates of Q. To find the coordinates of Q, we can find the position vector of Q first, OQ. And then the coordinates will have the same values. Multiple ways to do this. What's this first method? We're going to look for OQ, the vector OQ. And we're going to use these two vectors to find the vector OQ. We're going to use P as an intermediary point, the P. Because this one starts at P, at O, sorry, where the O starts. And this one ends at Q, where we want to end up. So to go from O to Q, we're going to go O to P first, using this vector. And then, plus means and then, we're going to go P to Q. P to Q. So that is how we can go from O to Q. We can go O to P, and then we can go from P to Q. All right? So the OP is this one, -2, 3. And the PQ is this one, 5, -4. That's going to give us our PQ. Let me make this a little bit smaller. That's going to give us our OQ, sorry, which is 5 - 2 is 3. And 3 - 4 is -1. So this is the position vector of Q. It means, therefore, that the coordinates of Q is 3, -1. No, look, this is not the answer, now, guys. This is the answer because the question asks for the coordinates of Q. That's just the position vector of Q. So this is the answer that we want. Now let's look at another way to do it over here. More maths equals better maths. Let's just do it another way. Or to do it another way, what we could do, we could take this vector PQ and split it up into position vectors. Split it up like this. So we have the PQ. We have the PQ. Let me zoom in and do it. PQ is 5, -4. So we have the PQ equal to 5, -4. And I could try to extract the OQ out of it. So split up this displacement vector into O times the last minus O times the first. Because an expression for PQ is this, OQ minus OP. That's all equal to 5, -4. Then to leave OQ as a subject, let me write this Q better. To leave OQ as a subject from this equation, okay, take this OP that is subtracted and bring it over here and add it. And then we'll end up with OQ being equal to 5, -4 plus OP. And what is OP? OP is just this, -2, 3. And you can see that you get the same result. 5 - 3, 5 - 2, sorry, is 3, -4 plus 3, -1. So that's how we could do it by splitting the vector equation and transposing. So this way is going to give us again, Q is a 3 - 1. Mute your mic, please. Mute your mic, please. Q - 1. So we could get it this way as well. So it's a nice little way to get it. Anything else to do? We're not done yet. One last piece, right? All right. Let's finish off with this. I'm going to take a break. I'll start the thing at 4 o'clock. The next paper at 4 o'clock. Oh. All right, let's go. This question says, pentagon, this OA is parallel to DC. This line and this line parallel. Mute the mics, please. Online, mute the mics, please. All right. So these two lines parallel. That's what they said. And AB parallel to OD. These two lines parallel. So they are multiple of each other. All right. So since this one is A, this one is in terms of A. And since this one is B, this one also is a multiple of B. All right. It says OD is 2 times AB. OD is 2 times AB. That kind of straightforward, right? Means that this vector is 2B, don't it? Because if AB is B, then this vector down here is 2B. Where you going, Mom? Where you going, Miss? This vector is 2B. I want to know how much I get. Where you going? Wait till I'm done. I finish now. Wait, man, I finish now. I want to know how much I get. I want. That's 2B. Then it says OA is 2DC. This is 2 times this. So it means then, if you look at it, it means that the DC is half of the OA, don't it? Don't it? And OA is that, right? Is A. So this vector down here, therefore, is just half of A. But I can see that? Good? You want to populate the diagram now. The more you populate the diagram, the better. OA is A and AB is B. All right. So what I want us to find out, the vector AD, going from A to D. We can use O times the last minus O times the first one. Because we have the portion vector of D or the portion vector of A. So we can use OD minus OA, right? The OD is 2B and the OA is A. That is it. 2B minus A. I could look at it this way. Come down here, so with a minus A, and then go across here, so with a 2B. So it could be minus A plus 2B. Same result. All right, what else do you want? Next part wants us to find the vector BC. Let's look at the diagram. BC. From B to C. All right. To go from B to C, we're going to have to go around the diagram until we reach C like that. See that? Good? All right. We're going to have to go around the diagram. So to go from B to C, let's add it up. We're going to go minus B here, so. But you can see why it's minus B. You're going against this B right here, right? Minus B. We're going to come down against the A right here. That's a minus A, right? Minus A. We're going to go add 2B down there next, don't it? Plus 2B. We're going to add a half A up here, so don't it? Plus half A. That will take us from B to C. But I say that. Let's consolidate the values now. This equals 2B minus B is a B, don't it? B. Half A minus A gives you minus half A. That's the answer. B minus half A. Very good? Nice and easy. But get 2 marks to that. On both side. All right. All right. So now do for the part, you know, last part. It says, take the conclusion about this is the length of AD and the length of BC. What's the relationship between them? All right, let's look at them. And these questions are parallelism questions, same way now. But I want the relationship of the length. So compare the two vectors.
Times 2.
Write them down for you. So the AD, not AB, the AD is 2B minus A, and the BC is B minus half A. Now watch me now. If you want to compare these two vectors, what we want to do is get rid of the fractions first, right? Get the fraction out of this one, because when it is in fraction form, it's more difficult to see the relationship between them. So to get the fraction out of this, I would multiply this one by 2. And when I multiply this one by 2, this will become 2BC. This will become 2B. minus A. Then what happens now that these two things are the same, don't it? Therefore, these two things are the same. So from the relationship, we see that AD is 2 times BC, don't it? So we can say that AD is actually 2 times BC. That's the vectors. But I want the modulus. So what we can do is just drop the modulus on both sides. Modulus this side and modulus this side. And then drop the arrows. Stop talking, I'm going to finish it. AD becomes 2 BC without arrows. And that's it, right? Now we can move this 2 outside and write about the same thing that they have. So the modulus of AD is 2 times the modulus of BC. That's the relationship between them. AD is 2 times the modulus of BC. Means that AD is twice as long as BC. I can see it on the diagram as well. AD is twice this long, twice as long as that. AD is twice the length of BC. So we can write that as well. AD is twice the length of BC. End of this test. And that is that. All right, before you leave, I want to know your marks. We'll start the next paper at 4 o'clock. So you have a nice long break. We'll start the next paper at 4 o'clock. All right, good. All right. Good. All right. Hey, remember, anything get wrong, work it over. Anything you got wrong, work it over. Practice them like crazy this week. Good. Practice them like crazy. Once again. 16. Yeah, we're work on them. And 40% we are work on them. Huh? What is it? 60. 40% we are work on them. Once again. All right. Yeah, Lee, why are you? Where are you going? Oh, all right. Make sure you do the work, you know, by the foolish. Once again. All right, nice. Those are some nice marks. What you get? Watch it. Good. Those are good marks. Good mark. Pass mark is 85. You know. Come. Hey, nobody tell them the mark. Don't come back, you know.
Sir, I'm getting 9. Yeah, that's 6.
What you get?
Sir, get it.
All right. What you get, Mom? With the SB or something. All right, we'll start the next paper at 4 p.m., guys. You have a nice lengthy break. Do the next paper at 4 p.m. What you get, my youth?
We need to go over transformation. Because those are the topics that my math teacher was teaching and during that time, at the same time, we get the other mark. So whenever they really have focus in our class, we just do our work, do the work, whatever they're saying. Sir, we say from grade 10.
I'm gonna do
So
maybe tomorrow. I maybe do tomorrow's class. I might just do 1 topic for the work or 2 topics tomorrow. I do a series of transformation and a series of vectors, something like that. Tomorrow for this week. So tomorrow, Wednesday and Thursday, I think that's what I might do. Because I really want to give these guys another paper Wednesday and Thursday. But for tomorrow, I might just do some practice first. All right, guys, online, we're gonna take a break, and then we're gonna do another paper at 4 p.m. It's about 40 minutes from now. But take a break. We're gonna do another paper at 4 p.m. All right. So, again, persons who can send me a WhatsApp and I'll send the paper. Those who not in my classroom can send a WhatsApp and I'll send the paper to them individually.